Hey. Hey, why haven't we deployed yet?
Oh yeah, well, the deployment process is a bit broken.
Who's Steve?
Steve built this like 5 years ago.
And then he left.
No, we need to deploy today. Oh! Fire! Fire, fire!
Find Steve now!
Hello, everyone, and welcome to day 2 of SHIPPED25. My name is John Bristow. Thank you for joining us here today. This is a conference that we do every year, and we've done so for the last 3 years. And it's basically a celebration of everything that was accomplished during the year by us, by you, our customers, etc., partners. And it's great to have you here with us. If, unfortunately, you were unable to join us yesterday, you would have missed an action-packed event. We had a bunch of great content there, but don't worry, you can see it all still. If you visit our YouTube channel, you'll see that all the videos are there. So we've already posted all the recordings for all the videos. All of this is put into a playlist for your convenience, and you can review all the videos that you may have missed during yesterday's event. So this is day 2. We have a lot of great content here today. We've got an action-packed agenda. We've got all kinds of sessions from a variety of partners and customers of Octopus, which is great to see. And I'm really looking forward to today. Lots of great stuff to see. If by any chance you have any questions about the event itself, all of them will be solved by simply visiting our website, which is at octopus.com/shipped. There you'll see a page that looks like this. This is where the stream is. You simply want to go here. This is the one place that will have the stream located. You may notice also that we're running the stream across a variety of different social media channels. That's to basically make it convenient for you to join. Feel free to submit your comments, your questions, etc. through the platform of choice. If you have any questions, let us know. For example, we'll respond to them accordingly. But we can see them all of them coming in from YouTube, Facebook, LinkedIn, Twitch, etc. Let us know if you have any questions, and we'll try and answer them live. As I said, we have a bunch of great speakers here today, which is awesome to see. In addition to that, you may notice that we also have a registration here. And the reason for that is because one of the benefits of registering is you're going to receive a voucher for this new course that we've just announced, which is Octopus Fundamentals. This is basically your first step of becoming an Octopus Deploy expert. And if you go to this page, which is up on our new site, learning.octopus.com, there you can read all the particulars about the course itself. So remember, it pays to register. So by registering, you'll receive a free voucher in the mail, your email, very soon for this course, which we've just launched, which is great. I also mentioned the fact that everything that was recorded yesterday, it's going to be recorded today. So that list that you saw on YouTube will also feature all the recordings of today's sessions. And finally, one thing I just wanted to mention is because day 2 is mostly focused on the community, it's focused on partners, it's focused on customers, etc. I did want to point out that our website, we've got a very vibrant community of folks like yourself building out continuous delivery solutions with Octopus. And at the bottom of every page, we have this link here to our community Slack. If you click on that, you'll see a page that looks like this. You can join over 7,000 other members of the community Slack by doing that. And just to give you a sample of what's there, we have our advice channel, which is extremely popular. This is where you can pose questions about various things you may have dealing with Octopus. We feature this in a lot of our shows. So for example, we'll go on and feature a question in our show Deploy on Friday, etc. But if you want to see events, if you want to see other announcements, etc., you want to see blog posts, all that will be featured on our community Slack, which you can join directly from our website. All right. So again, octopus.com/ship. This is the one place to go for the stream itself, and we will see you there. All right. So with that being said, I'd like to introduce our first speaker. Dale is joining us. Hello, Dale. How are you?
G'day, man. I'm good. How are you?
All right. Awesome. Dale's going to be delivering a session entitled "Where Do My Variables Go?" So Dale's the Director of Engineering of Product at Climavision. I'm really looking forward to this session. Dale, thank you for speaking. Over to you.
Thanks, mate. So this is something that honestly I could probably do an entire series on. For now, we're going to get into the 35, 40 minutes that John's been able to give me. If you have any questions, don't hesitate to put them up, and I'll try to get to them as they come in, but likely will be more towards the end. So for many of you, I imagine that one of the big questions you're always asking yourself is, where do my variables go? If you've worked in Octopus for any length of time, you've probably had that moment of hesitation of not quite knowing where it goes. In Octopus, there are four core entities that relate to your variables. Those are environments, tenants, projects, and variable sets. And the relationship between these isn't always obvious. Like Octopus is flexible, it doesn't force strong opinions on you. And that flexibility is its strength, but also means you have to decide where things go. Like you have to have an opinion. Today, I'm gonna try to give you a bit of a framework, a set of guidelines that I've worked with and worked well over the years. And by the end of it, you'll hopefully have a clear mental model for how this kind of works. Before we get, I'm trying to figure that one. There we go. Yeah, so before we get to the solution, let's understand why this is confusing in the first place. And Octopus actually has two separate ways to scope variable values. The first, and I'm not sure how to zoom in, but is that one on the left, which is simple variable scopes. And John, if you're around, I don't know actually how to jump to the screen. On my screen. Should have asked that first.
No, you're fine. You're fine. Let me go ahead and add the other screen there.
There we go. Yep.
Yeah, just let me know and I'll switch it for you.
Awesome. Thanks, mate. Yeah, so the first ones that you tend to have are these variable scopes. So really straightforward, really simple. You can jump in, you can decide how it works. You can base it off of environments, tags, processes. You set the value and it applies when these conditions are met. The mental model here is like, here's a value, filter as these scopes apply. The second is tenant variables. This one's a little different. It's not about filtering, it's about filling in a matrix. For project variables especially, you need to provide a value, and we can show an example here. Just give it a test one. If you do it here, and I've got two tenants set up, you kind of have to provide a value for every tenant, for every environment, which is intentional, but it's a different way of scoping, for scoping your variables. And then you've also got common variables, which are the variables you can have across all tenants, but not relating to a project. So it means that, like, in project variables, even if you have the same variable, across 50 tenants, you still have to put it in 50 times. And if we go back to project variables here, you'll notice one thing that's kind of missing, and I believe it's a deliberate choice of Octopus, is there's no tenant option in here. You've got role, channel, process, but yeah, no tenant. You can get tenant specific values in here as we've discussed, but the way that you've got to do this I lost my spot. Even if this project is only a consumer of something like a database string and things like that, it's hard to get it to have a tenant only one without going through the process of actually setting up a variable set or use an existing variable set and then putting it in the variables. And it works in the, geez, I'm losing my mind. Sorry, give me a sec. It works, but it forces you out of project variables. It puts you in a different area. You've got to go to tenant variables, or you've got to jump out, leave the project, come back in. Sorry, leave the project, go into variable sets, edit, come back in and make sure things are looking correct. And honestly, I think this confusion tends to be where this comes from. So when I've trained other people, this struggle of like, is it in a variable set? Is it in a project? Is it in tenant variables? Where do I put it? Has tended to be the course sticking point for most people. We can jump back to the slide if we want. There we go. Now, the framework. We'll jump into it and get a little bit started here. And the first guideline that I would have is always use tenants from the very beginning. Even if you only have one tenant today, just go and create a single one on there. We'll jump back to the thing. And I'll show you an example. Here are my tenants. Pretty straightforward. I've just given an example here. We've got company and company A. Pretty simple. Honestly, you could have this be called default, go with the company name, doesn't matter. Just something that's standard. Adding multi-tenancy later to the system that wasn't designed for it is incredibly painful, trust me. The next thing that I tend to do, here we go, is add in a core configuration variable set. This is kind of a catch-all for all of your company's variables. Kind of like you have system variables that Octopus comes with, these are your company's system variables. It combines, at least the way that I've done it, the tenant identity and your naming standards. So first you can see in here, I tend to put, and this is just, by the way, this is not my actual company one, this is an example one I whipped up. But in here you can see examples of tenant identity items. You've got things like key and your tenant account, domain suffixes, owners, just things that show up as the tenant's identity, anything that's about who the tenant is. You'll notice that a lot of these are prefixed. I'll go into that a little bit more shortly. But the other ones that I set up are things like your core naming standards and naming conventions. A few examples I threw in here are things like domains, resource names. So this is something we run all of ours in Azure. So I'll just say this is something, if you're running your stuff in Azure, this is a naming standard that we chose. And then I copied that for our Kubernetes release names and created a similar one here. I add other little fun keys like environment keys to make things just a little bit easier for when I want to use that in things like these names. We also tend to define a RACI for any one of our projects. And this shows up here as a nice little example for things that we can put into annotations on our K8s deployments as well. You'll notice here that these all have prefixes as well. These ones do core. Not necessary, but it makes it clear. When you're looking at in your project, and we'll look at it shortly, but when you're looking at a project and you can see the variable examples and you look through, it makes it really quick and easy to know where they're located and how to get access to it. The other ones that I then do, after I set up the core configuration variable set, and the next thing I tend to do is I'll actually create variable sets based off of the bounded context in whatever domain I'm working in. Your variable structure should and easily can mimic your architecture. So the other one that I'll do is this shared infrastructure. Now, this one may feel like a bit of a smell, but I've learned to treat it as a bit of a staging area prior to variables finding their home as well. But this holds variables for resources that exist across multiple bounded contexts, as well as, yeah, mostly just stuff across multiple bounded contexts, but the stuff that we also stage. These are things like, observability endpoints, your logging, your shared service buses, any sort of common database if you needed it, any common infrastructure that doesn't really need to be relative to any bounded context. You just keep it in there. I've given a good example of a database in here, a nice little open telemetry endpoint, and then something simple, a top-level domain. And then each bounded context in here has its own variable set. So if you have a payments domain, you have a payments variable set. If you have an orders domain, you have an orders variable set. In here, I've created an example for an accounts and a notifications. The beauty of this, and it depends on how skilled you are in it, is if you use infrastructure as code, you can actually use and we use a lot of Terraform, so we've got to use the Octopus provider. If you create a Terraform project that goes and sets up all of your infrastructure for your bounded context for this piece, it could be accounts and notifications, you can actually have that set up and manage your variable set as well, and you don't need to worry about it. Similarly, if you use that infrastructure as code and you have tenants, by using this and making sure that you have tenants as a first-class consideration, you can have all of these managed really nicely. Now, let me show you how this all comes together inside a project. In here, I've created a few different examples, and you'll notice that I tend to also group my projects based off of bounded context as well. That just keeps it nice and neat, nice and simple. Let me open up. Oh, here we go. Okay. Now, this project here includes like core configuration, shared infrastructure, and all the bounded contexts. If I grab the right one, actually, I'll go to the other one. I think I set that one up a little bit better. Here we go. There we go. Yeah. And we can kind of see how this all pops together. So if we jump in, and I'll show you the variable sets. Yep. So this has got the accounts bounded context, the core configuration, and the shared infrastructure. Keeps it nice and simple. Now, this is actually something I was so ecstatic when Octopus added this about, I want to say 6 months ago. And it makes things really nice, but it's also definitely going to make this presentation nice and easy. So before I jump into some of those things, I wanted to show you something which is maybe a bit shocking. Is I don't have anything in project templates, and here's the key insight that kind of simplifies everything, which is that if you have variable sets with your bounded context, a set for your shared infrastructure, and a set for the core configuration, I've actually found that I accidentally don't use tenant project variables anymore. It stays empty on pretty much every project. There are things here or there that we've ended up using it, but for the most part, yeah, I don't use this. Everything that would go here has a better home in one of the variable sets in either the bounded context. And honestly, this is huge because it kind of removes a big section of your decision tree. You're no longer choosing between project variables or tenant project variables or common variables or variable sets. It keeps it relatively simple because you're kind of thinking about this from the top down, really. Now, I want to go over some practical patterns here. So what does go into project variables? And honestly, not a lot either. The only things that I really ever put in here for me, now that I've done the other pieces, are things that are completely owned by a singular to this project. So values that this project creates and is only like the only consumer of, as well as values that matter only to this project, like project specific configuration. So environment variables unique to this service, so something you need, variables that per project that are referenced in variable sets, and I'll show you that what I mean by that in a sec. One sec. Because in core configuration, as an example I showed there, is where you really define your naming conventions, and these templates then get referenced with ones we put at the project level. Things like you can see service type, service name, these are all defined here, and then they're consumed in those naming templates. So if anything else might consume it and you would have to change it in multiple projects, I tend not to put them here. I put them in project variables. Now the star there is, don't hesitate to lean on the rule of 3 either. As in, if you only have to manage it in 2 or 3 locations, yeah, it's fine. You can keep it there. You don't have to add the overhead. But any more than that, highly recommend you jump and put it into a variable set. Now, something I want to kind of cover here is a good example and something we lean on relatively heavily. We'll jump back into variable sets to do that. Are these naming conventions, or I call them composed variables? In here, what I've done is defined how all of our releases get named. Now, this is more Kubernetes, but it works regardless. Anything that requires you to define a name. In this example, this is the type of service, the name, where it's what environment it's in, and kind of where it's located or what it's for. It actually comes from a convention Microsoft defined, and it's why our resources are named in a similar pattern. You can see this one in here, almost identical. And then I've done a similar one, done a similar one here for subdomains. Now, that's not to say that you hard code this and this is how you would do it for every single project, but inside your core configuration, this is where you define your defaults, where people can lean on it and don't have to do it, don't have to worry about it. And you can do some cute things like this. I don't know if anyone or many people know about it, but this is actually like the default example that they'll show you how to do an if in the documentation, but basically just says that if it is defined, then add it in. And this gives us a lot of power because in my default subdomain, I've now made it that if you have a domain suffix defined, it'll add it, but if it doesn't, it keeps it nice and neat. And it just gives me a nice little, in my projects, when I put an ingress on the project, gives us a domain that I don't have to worry about it, and a consistent naming convention, which is what this is all about. You don't have to worry about it, it's in there. Similar actually is one of the reasons we added in this one, but we added as an annotation onto a lot of our K8s deployments so that if anyone's jumping in and looking around the resources, they don't have to leave out. But this would be a pain to do if you're doing it on every single project. But if you define these things from the beginning, you can kind of go do these, cute little things like this, and you don't have to worry about it. It just exists. And things like this domain suffix makes it nice and simple because you'll define them in your variables, and you'll make it usable, and you use it in each of your tenants. Now, side note, I don't know if anyone might have seen this, but this is a fun little thing you can do for anyone who actually wants to have common variables or tenant variables, but you need to have a blank value. The reason that exists is because if you have the default value blank on it, it'll actually ask you to specify you actually have to have a value. So just a fun little piece there. And then what does this all look like on a tenant? It jumps in. Apparently I didn't get it all ready, but it jumps in, and you can go in and fill out all of these. So I do things like have the tenant key and just give it a unique little ID. You can set up your accounts, obviously. And you'll see here and this is my default tenant, you can have the suffix be blank. And then, things like tenant owners, location abbreviations, all these fun little things you can kind of set up. And there's a database in here. You can see the bounded context has its database set up. And then if we jump over to the other tenant, you can go get all of those worked out, plain and simple. And yeah, so different key, different owner, different set of notifications and accounts databases. Doesn't have to be though, like you could put in the same one if you wanted, or you could even use the default. It's up to you. Now, if we go and look at some of these other projects, you can see the way that these composed variables work. So where's my release name? I'm going, here we go. So you can see that it works nicely in here. Now I've defined the service type as a microservice. This is its name, this is its environment, and this is the tenant that it's for. Now, this is super powerful. And the reason is that when you go and add a new tenant, say you have a new integration partner that you're bringing on, you need to make sure that they have a stable environment to do. You don't have to worry about any sort of conflicts. You could spin it up in the exact same environment as the others, because you would just go and add in a new tenant, update those variables that we just showed, and change it. And automatically, without you having to change anything inside your project, it has a new release name. It could even have a new database. We would have seen this one change. Any of those pieces done, and the power of that is all in making sure that you're using those composed variables. It keeps things really straightforward and really simple. You see things in here as well, like the Racy did the same thing. And the reason for this is because the power of Octopus variables is that it also, because it's dynamic, it also doesn't enforce hierarchy. So, and it's actually infinitely recursive, which is awesome too. But you can set all of these things at all these different levels. So you can have variable sets that reference, as silly as it sounds, variables inside your project, because it won't blow up. It does this instead and just leaves it in there. It couldn't replace it, so it doesn't replace it. It keeps it nice and simple. But if you want to, you can change anything in here and you'll see that jump back in. Oh, I just had something pop up. I thought someone asked questions. Pardon me. So it's pretty straightforward. Now, I've kept it pretty simple with my examples here, but you can go pretty deep with it. You can keep it as simple as you want or as complicated as you want, but I've put some of the ones that we've got have a lot of smarts in it, very similar to these ifs, just to keep the complexity in one location, meaning that you don't have to put it in project after project after project, and it makes things straightforward. Because Octopus does all of the work for you. We're paying them to do the deployments. We might as well have them use all the power that they've got. Now, we'll jump back to the slide just because kill some time in that. But yeah, use variable sets to keep it nice and organized. Start off with a core configuration. Start off with getting a shared infrastructure, a place you can stage any of your common infrastructure that you may want to use, and where you put some of your variables ahead of time. And then one for each of your bounded contexts, things like accounts, notifications, reportings, orders, any of those ones. It keeps it simple. Now, to the decisions. How do you decide where the variables go? I really just ask myself two questions. What's responsible for creating the value, and what consumes the value? So if the same project creates it as well as is the consumer, then leave it in your project variables. And what I mean by that is, if inside your process, and none of these actually have a process, but if inside your process, you're spinning up a service bus, or you're spinning up a namespace, or I don't know, insert something here, maybe you've got some kind of, you can leave it in there because it's only going to be consumed by that one project. You can store that value in there. Now, sorry, I should say, you won't spin up your infrastructure in a process, you'll do it in a runbook, of course, but same, but different. It goes in the project. If 2, 3, 4 projects are going to consume it, chances are it's probably already a bounded context, and you're better off looking to try to manage that inside a variable set. It makes it simpler when you have a new tenant. It makes it simpler when you have a new project. You don't have to copy paste, and a lot of the times it feels like you're doing a lot of work up front, but honestly, it saves you in the long run. And this is the way that I'm going to show you here, or the way that I've shown here. We've done this in 4, I want to say maybe 5 different companies that the crew that I hang out with has done with their startups. And every time we found that it's been helpful to start with tenants, start with variable sets, and manage it that way, because it means then that, you know, when we're rapidly prototyping and we're setting up a new project, it's not difficult to do so. Honestly, I'd love to show you one of our other repositories, but sorry, other spaces, but in that one, whenever anyone has had to set up a new project, they'll just grab one of the other ones, clone, change which package it's pointing to, quickly edit the project variables that matter specifically to that project, and they're deploying in 5 minutes. It's really, really straightforward. And that's about it. You don't have to worry too much about it. Now, to wrap it up a little bit, and I'm kind of at the end here, I had the 40 minutes and I wanted to make sure I had 30 to give time for questions, so I can ramble a bit more about other pieces afterwards, but I want to leave you guys with a few thoughts and talk about the mistakes I've kind of made often. Touched on to a few of them, but honestly, not creating those patterns in the variable values, those composable variables, it led to inconsistency and drift. As an organization, 9 times out of 10, you'll define how you want things to be named. Now, what I mean is you're not going to all sit around a room and design by committee with what it is. You'll just naturally gravitate towards a structure that you name. And it's better to make that concrete, put it in there, and then that way nobody has to worry about it, because honestly, most engineers are lazy, and if they can have someone else do their pieces, they will. So be the person that does the paperwork and go define it, put it in the variable set, and everyone will keep using it. The other one is not using tenants early. That's not to say you can't have projects that aren't untenanted, but the default should be tenants. Create a company tenant, you don't lose out on anything, and use it in there. Then that way, you know, because as everyone knows, with the way Octopus operates, everything's dynamic. You get to choose how it operates. So that means that if, as an engineer, you want to have, and I understand they've just added ephemeral environments, but if you wanted to start to have your own environment as an engineer, something that's ephemeral whenever you're doing your PRs, it's really straightforward for you to do so. You know, you want to spin up your own CI environment, you can. You just go create it with your name, put all the details in, and instantly you're off to the races deploying for just you in there. And because of things like those composable variables, those naming conventions, especially if you put in the tenant key as part of it, you can deploy in the exact same namespace as your dev resources or your production ones, because you won't get conflicts, because you design your naming conventions to avoid those conflicts, to include things like a tenant and an environment. And if you wanted to live crazy, yeah, you could put all your environments in the same cluster as well. Depends how your infrastructure people want to operate. The other one is, yeah, not focusing on reuse. This kind of touches on that: composed variables, variable sets. Just honestly, take the time. You know, the longest path you'll ever take is the shortcut. So take the time, sit down, make sure that everything's in your variable sets, that you focused on that reuse. Things are easy. And that I've touched on a couple of times, but your deployment lifecycle should be boring. Even from setup, like especially from setup. Even if every project is a special little snowflake, which is actually where we got to, and we've worked hard over the last 6 months to avoid that. But if every project is a special snowflake, with its own variable structure, own deployments, you'll spend more time debugging than you will be deploying. Or worse, you'll be scared to deploy. You'll hesitate. You'll start moving into that company that'll deploy every 3 months instead of 3 times a day. Now, to recap a little bit, understand that there are 2 scoping systems and evaluate where the variables go based off of that. To be clear, that's not to say that one's better than the other. I've just tended to lean more into variable sets and scopes. It's simpler, easier, and fingers crossed, one day, hopefully, maybe Octopus will give me tenants as a scope in that area. Start with tenants from day one. Never hurts you, takes 2 seconds to set it up. It's a minor little pain every time you start up a project, but it'll, trust me, save you time in the long run. Create your core configuration variable set, put in your tenant identity, set up your naming standards, get those composable variables ready to go, and then mirror your architecture. Anything you do, even in small projects, are going to have some form of a bounded context. Set up variable sets related to them. Your life will be way easier. And then keep project variables tight and light. Only single owner, single consumer values, really simple. And then when in doubt, just ask yourself, who created this variable and who consumes it? And that's it. Thank you, and I'm happy to take any questions.
Awesome, Dale. Thank you very much. That's great stuff. I was laughing off stage here because you're like, your deployments should be boring. I'm like, my deployments are exciting. Come on.
Yeah,
what are you talking about? I'm totally in agreement. Don't worry about it. We've got some questions here, but some of them are facetious. Obviously, Bill asking, so you're telling me that either global variables or no variables is bad advice. Thanks for that. And of course, Steve had a good chuckle about that. One question that did come in here from Rob, he says, if you have the same variable name defined in multiple variable sets, and both variable sets are used by the same project, which value will be used?
Good question. I actually think it won't let you, but actually no, it will, and I've run into this. So let me see if I can get to the project where I'm at. Yep. So when you add the variable sets, it's ordered. I believe, and don't quote me on this, totally just go test it out. I believe it does it in the order that it appears in here. Now this is ordered by name, but there is an order for how it gets added. There's an order for how it appears. And in one of those orders, it will choose which one it does. But
there you go.
That's where I would totally just set up an experiment, jump into variable preview and have a look. It could also be a flip of the coin. And I'm just saying that as an engineer and how sometimes I would implement something like this.
I think it comes down ultimately to, well, the resolution logic is based on basically, there's a whole bunch of scopes that we also apply to variables as well. It depends on how those qualify. So there are things worth noting there. One other resource I did want to briefly mention here is we have a session by Matt here. This is Matt Alford, who's our developer advocate at Octopus. He did a recent video up on our YouTube channel called Variables in Octopus Deploy. So Matt does one of these videos every now and then. It's called Exploring Octopus Deploy, where he talks about what are variables, how they work, etc. Talks about scoping resolutions, etc. And so that's something that you can definitely check out there if you're so inclined. All right, take a look at some of the other questions here we might have for you there, Dale. We've got a question here. May I please have the recording of this session? And Tony jumps in here. Thank you, Tony. All recordings are going to be up on YouTube. They're going to probably show up in the next 24 hours. Hopefully less than that. But as the kids like to say, like and subscribe. And Tony was gracious enough to share with us the YouTube channel. There you go. Awesome. Rob did post a follow-up here. And would a variable defined in a project override a variable in a variable set added to that project if they have the same name?
Yes, they do, I believe. I don't know if you know for sure with the John, but I've done that before, and it'll override it. The one thing it won't do, which I wanted it to do a while ago, is if you set a variable set with a, if you set a common variable and you don't define the value, it'll have you fill it out. You have to define it. Or if you set a variable where you have to request it when you do a deploy, where you need to fill it out, I thought I could do something like that and then have it override it locally inside the project and say, oh, here's like every project will then define that value. It won't let it, but the projects do override those variables. I've used that before.
There you go. Yeah, the documentation on this is pretty thorough. But you know what, Rob? Awesome. Why don't you post this to the advice? I'm going to do a callback now. So we have our community Slack. Post this to the advice channel there, And hopefully you might get an answer in terms of the absolute. But if you don't, I'll make sure to cover it on a next edition of Support on Friday, which is a segment we have on Deploy on Friday, which is a show we have that we host every week. So there you go. Thanks for the questions, Rob. That's awesome. And then, of course, Tony here had to say the longest path you'll ever take is a shortcut. Awesome. Well, Dale, thank you very much for your presentation. Again, Dale's talking about variables there, so you'll check that out, obviously, on our YouTube channel after the fact. So thanks a lot for that. And Dale, thank you for your presentation. Really appreciate it.
Thanks, man. I enjoyed it.
All right. Take care. All right. So let's now go back to our schedule here and take a look. Once again, welcome for those who are showing up late. That's okay. I get it. Early in the morning to join the session. It's really early for me. It's midnight, but that's okay. So coming up next, we have Dennis from Croz talking about seeing your value chain clearly, Octopus Deploy, and Apache DevLake. This is a session from the folks over at Croz. Croz is one of our partners here. You can find out more about them by visiting croz.net. And they did some sessions last year. They're doing some sessions this year. And this is one of them from Dennis. And then following that, we've got Bernhard, who's going to be doing a session entitled Scaling Compliance in Regulated Environments with Octopus Deploy and Nape. And remember, just to remind folks, we are streaming everything on our YouTube channel, and this is streaming through the Shipped website. You'll see this all listed here. So visit just octopus.com/shipped for everything that you want to see in terms of that. All right, well, without any further ado, let's go ahead and get into Dennis's presentation.
Hello, everyone. Welcome to our talk around how to see your value chain clearly with Octopus Deploy and Apache DevLake. I'm Denis Jajcevic. I'm a principal solution and platform architect at Croz. And for more than 15 years, I'm doing this part where we actually try to see how to increase and how to improve the value chain in company's organization. So today we'll be talking about a practical demonstration on how to integrate Octopus Deploy deployment data with Apache DevLake that will complete the DORA metrics picture across your delivery value chain. And we'll discover how objective data-driven insights will help you to identify real bottlenecks and drive continuous improvement. So to start off, let's talk about why would somebody use DevLake if Octopus Deploy has its own DORA metrics. So Octopus Deploy tracks DORA metrics from its perspective. The metrics are calculated in real time based on deployment completions. And Octopus does not see incidents happen after a successful deployment, for example. On the other hand, DevLake sees the big picture, consuming information from all sources in the value chain and connecting the dots. With DevLake, we're able to get more precise DORA metrics, analyze cycle time end to end, even gather and analyze security and compliance statuses, thus enabling cross-system bottleneck detection. Octopus is essential for operationalizing deployments, but DevLake is essential for understanding the performance. So how does DevLake complete value chain visibility? DevLake is a central part that unifies analytics, connects to various systems, various sources that you have in your platform. One being GitLab, that could collect and is collecting actually commits and PRs. The other one is, for example, Jira, that collects issues and cycle times. Another one for static code analysis for code quality in CVEs, we maybe use SonarQube as our connection. And we use, and actually DevLake uses pipelines to analyze the build time and the test execution time. But also, most importantly, we missed the part where we used Octopus Deploy for managing deployments then we use that data, ingest it into Dev Lake to complete the whole picture. So what is actually Apache Dev Lake? Now that we see that there is a value of using something like Dev Lake, let's talk about what it is. Dev Lake is an open source development data platform, providing the data infrastructure for developers team to analyze and improve their engineering productivity. They're exiting or near exiting the incubation phase. So from the picture, you can see that you can, including just DORA metrics, you could also analyze the engineering metrics that have and various data that you gather from the connections already built in. Who benefits from Apache Dev Lake? For one, engineering leads helps them to understand project health and trends. Development teams, it helps them to identify bottlenecks and slow-moving work. Like, for example, if we have more incoming tasks than we are finishing. Infrastructure teams, it can help them, especially when infrastructure changes are managed via tickets or infrastructure as a code. For platform teams, it does support a product mindset with measurable metrics. And of course, not to forget the governance and compliance officers. It enables them to track the resolution time of any related issues to governance. So essentially, anyone who's looking to make better sense of the value chain and to use data-driven approach in these practices. The concept around Dev Lake is very simple and extensible. Dev Lake supports many data sources like GitHub, Jira, Jenkins, SonarQube, DApp, and many more. The flow is that using those in connection points, those plugins, data is fetched, transformed, and pushed down to other framework parts that analyze, calculate DORA metrics, for example, and store that in a common model inside of a database. All data is visualized via Grafana dashboards querying the database. So how to get increased visibility from zero to hero, so to speak? So first of all, you need to set up a Dev Lake. You can install it via Docker Composer or Helm, be it on any Kubernetes platform. Create a blueprint, configure it through a UI, connect projects to one, and track the progress of that blueprint. Now, the obvious next step would be to view the pre-built dashboard, explore wherever it is happening, discover bottlenecks, even discover what you thought you understand that is probably a different situation. And then, of course, since we're using Grafana and have a database as a source, we could build our custom dashboards using that. How to use, and let's get a little bit acquainted with Apache's Dev Lake UI. So we've talked a little bit about projects. So projects are grouping multiple data scopes under one umbrella. We've shown those 5 data sources Dev Lake can use. So for this example, we can have source code management, PR reviews from GitLab, and watch the tickets also from the GitLab. But also, we could have webhooks to gather information around deployments. But if we, for example, have another project that uses Jira for its issue management or project tracking, we can connect just that project with that Jira under one umbrella and get the metrics for that project under the same data format. Pipelines are auto-generated depending on your connections, on your data sources, and enabled functionalities. For example, DORA metrics is one functionality that you can enable or disable to calculate. So it actually does gather information from various your connection points for your selected project, so it's scoped. And depending on the plugin, it is incremental. And then using that data, raw data, extracting critical or important information and transforming it to common data model that's able to browse, to explore via Grafana dashboards. Next up, we have webhooks for data sources that are not covered by built-in plugins. And this is where Octopus connects. This is how we register our Octopus deployment to the DevLake project. One highlight worth mentioning, and definitely I would say that this is one of the greatest documentation that I've ever seen, is DevLake's comprehensive documentation on all available metrics. And in that documentation, you find out how that metric is calculated, why it may be important for you, and if you want to focus on it, how to improve it. With also a list of required data sources and a list of dashboards that metric can be seen. As we mentioned earlier, all visualization is done via Grafana. So for one example, we can have a DORA metrics dashboard that shows these 4 key metrics in one dashboard, filtered by projects, where you can see if there are any outliers in your current situation. One example of detailing those key metrics is another detailed dashboard for failed deployment recovery time, where we can see how much we are spending, or how long do we need in order to fix a failed deployment. There's also a DORA details change failure rate dashboard that we can see if there are any incidents correlated with any other deployments, and then we can drill down to see if we're having too much incidents or we are having too much deployments that are failing their customers. Of course, since we use Grafana and we have database as a source, we could build up our custom dashboards. For example, this dashboard shows how to query tickets or issues or incidents that we have in our database, in our DevLake database, and get a better sense of that data with what we need. So how this whole concept we've made looks like. So how it works when DevLake meets Octopus Deploy. So in the middle, like we've seen in the first picture, we have Octopus Deploy. It's our continuous deployment tool. When developer commits some code on a GitLab, for example, it triggers a pipeline, it builds, it tests, and it also initiates a release on Octopus Deploy. What that release triggers then is various checks. For example, we can run assurance policy checks using an ape. And then user manually needs to approve upon a failed assurance policy check. Then, if everything is okay and that deploy has a green light to be deployed to the target runtime, upon deployment, we register our results to DevLake, including starting the blueprint to recalculate the information. That all registering, deployment, and triggering is done via process step on Octopus Deploy. Worth noting that when I mentioned Octopus Deploy assurance policy checks, we've implemented with a tool called NAPE. After me, there's my colleague Bernard Hopfmüller, who is going to be talking about how to automate governance on Octopus Deploy. And now, the demo time. Let's see how it all works. First of all, we're going to explore a project that's already on Octopus Deploy. It's process. So let's open a project, then go to process and investigate what do we have at the moment. From the picture we saw before, what we have is those assurance automated checks, automated governance assurance checks. Then we have the manual approval that happens if those checks fail, relieving the manual toil from the people who need to approve if there are any issues, and relieving them from manual checks. Then we do a deployment that can be successful or not. And then what we do is register our Dev Lake deployment. Well, now when we create a release, deploy production, of course, it's worth mentioning for this demo, we've skipped all the previous environments and going directly to production just for this demo. So after the automated governance step, when we see that everything is A-OK, we perform a dummy deployment. And then register deployment to Octopus Deploy. I'll skip the parts that you're going to see on Bernie's talk and go to the part where we visualize the data on the Dev Lake. So this is the same step that we've seen before. When we deploy and we register the deployment, we can see in this Dev Lake's UI that we've triggered the last, it's a 50, the pipeline that's going to collect, and it is collecting the data from GitLab. It's collecting data for source code, so for PRs, for commits, for pull, so the review of the code, but also since it's configured to collect issues from a separate GitLab project, we collect CVEs from those and use it as an incident reporting tool to actually demonstrate the CVE GRC resolution time and to present it on Grafana. This pipeline, what it also does is after collecting that data, it calculates the DORA metrics and presents it in that common model in a database. And when it's finished, it takes a little bit. Finished. When we go to Grafana dashboard, we can see that our value change depending on what happened to the deployment. And also we have a dashboard that says, okay, you have this amount of open CVEs, this amount of open GRCs, and how much time. Of course, this is all demonstrated stuff, so it's not the real case, real case data. It's just to demonstrate the possibilities of the Apache Dev Lake. Okay, so let's go back to the presentation. So to wrap up things, we saw that Apache DevLake is a really powerful and open source tool for data-driven value chain insights. It enables us to collect various different connections and data sources under one project and treat that one project as a one unit to calculate Torah metrics, engineering overview, and even the CVE resolution time. That enables us in our diverge ecosystem where we have multiple tools. For example, if there are some projects that use Jira, there are some projects that use GitLab's ticketing system or GitHub, we can use and connect all of those data to one place. Of course, the missing part when we have Octopus Deploy as our continuous deployment tool is that we miss that deployment part from Octopus. And Octopus and DevLake together help you to see that value. So when we integrate the Octopus Deploy with webhooks, we are understanding that value chain more clear. We have better value or better understanding in the when decrypting the bottlenecks, when some deployment has actually been a deployment that caused several incidents on the client side. And this data-driven approach enables us to, with actual great open source tool, to visualize that data, create alerts maybe, to have a more in-depth analysis into how our value chain works and if we're satisfied where it is going. Of course, we've talked about governance and resolution time around CVEs, so GRCs. After me, like I said, there's my colleague Bernhard that will talk about how we did automate that stuff inside the Octopus Deploy process and how we can actually relieve the GRC officer's value or just help automate stuff on the governance side. So once again, thank you for joining and seeing how you can see your value chain clearly with Octopus Deploy and Apache DevLake.
All right, welcome everybody, and thanks for joining in on my talk on scaling compliance in regulated environments and how you can do all that combining Octopus Deploy and Nape. My name is Bernhard Hopfmüller. I'm with Cross. I will talk a bit about Cross later in my talk. So for now, I want to start with something completely different. And that's the question for you out there, whether you like dogs or not. You might wonder why I'm asking that, but bear with me for a second. It will make sense. Trust me. So regardless whether you do like dogs and maybe even have one, or you don't have a dog, you will encounter signs like that on your everyday park walk, right? You will go in the park and you will see a sign that says, keep your dogs under control. And if you now see a person that actually has a dog and the person who really doesn't like dogs, you will see different interpretations of that sign. A person who really doesn't like dogs or even is afraid of them will say, oh, great, there are no free roaming dogs here in this park, so I can just walk in there, take my run, take my stroll, and it will be safe of those vicious beasts. Until the point one of those things starts running at you and almost hits you over. And then you might, depending on the dog owner, hear a whistle and the dog will return to his or her owner. And you will potentially get into a fight with that owner person, saying, hey, why don't you have your dog under control? And that person will say, well, but I have it under control, right? I gave a whistle and the dog returned to me. So you can see there's sort of an ambiguity in that keep your dog under control sign here. It could mean that your dog is actually on a leash. It could mean that the dog is voice controlled. It could mean, hopefully not, but it could mean that the dog actually has a shock collar. Or it could mean even that the dog is in a fenced area, or 100 other interpretations you could put into that keep your dog under control sign. To make it even more absurd, even a sign like keeping your dog under close control and indicating that here with a leash leaves room for interpretation, right? Because you could say, okay, I'm carrying my dog even though it has a leash, if it's a very small one. You could say, okay, my dog is under control with a long leash, with a short leash, or I'm a person that actually needs a guide dog, so I have my dog by me guiding me around. You can see there's a lot of room for interpretation, and you can encounter those things not only with dogs, but in your everyday life scenario. Imagine just the last conversation you had with your significant other when he or her said, she or he said, how about you clean up the apartment, right? There's a lot of interpretation for that also happening. And there's a term coming actually from philosophy defining that thing, and it's called open texture. Open texture means there's a term to refer to the universal possibility of vagueness empirical statements, like the one with the dog under control, or the one like our apartment should be clean. And here's another one that might maybe sound familiar to you or not, but I will just read it out. It goes like, financial entities shall implement the ICT business continuity policy to ensure the continuity of the financial entity's critical or important functions. Well, that says a lot of everything and a lot of nothing, right? And that actually is from the Digital Operations Resilience Act, or DORA short. And you can see that that DORA thing is, if you go back to what we defined before, a lot of open texture and a lot of not very concrete what that means. So if we look at regulations like DORA, we can say DORA is open texture. DORA describes an outcome and not an implementation. DORA will never say add health checks for your load balancer, right? DORA will only say you need to ensure operational resilience. And it's up to you to define what it technically means. So your job is it to add texture to that thing. And depending whether you are now actually a techie or a person in higher in management, it leaves the same story, right? It's up to you to define what DORA means, and you are responsible on a different level of that. You might ask now, or have asked yourself in the past, if you had to deal with DORA, or for that matter, any other regulation, how do I do that? Well, the same way an open texture thing leaves you a billion possibilities to interpret it, there's also a billion ways to actually achieve it. But here's one that I want to show you. And that one consists of 5 steps. The first step is we identify a risk, right? The second one is we define a rule for that risk, how to deal with that. The third step is we verify whether the rule we defined is actually met. The fourth step is we evaluate the result of that verification, whether my rule is met. And the fifth step is I act upon the evaluation of the risk. And we give those 5 steps names, right? We call them risk, control standard, assurance, risk evaluation, and control procedure. I know this is, again, very open texture now for the moment, and you maybe cannot really imagine what that means on a concrete example. Don't worry, we'll get there in a second. For now, you might ask yourself, why are we even doing this, right? Why do we even need to do those 5 steps or 100 other steps you defined for yourself to fulfill that regulation? And now I spoiled it already. You might say, okay, I'm doing that because I have to, right? Because one day an auditor will show up and say, hey, how about you show me evidence you're actually doing what you're claiming you're doing, right? And nothing that sentence basically captures the essence of what an audit is. An auditor will want to see evidence that you're actually DORA compliant. Well, the difference between an audit and assurance is this one. A DORA requires you to show proof that you have operational resilience. And assurance proves with evidence that we actually do what we say. And an audit is then nothing but checking that the proof we collected already is correct. So basically, an audit is only saying, well, you have some evidence there laying around in your company. How about you show me whether your story around that checks out or not? So you should actually assure for yourself, right? You should not make assurance in order to be only DORA compliant, but you should, because you probably have an intrinsic motivation to be resilient against all kinds of things. And that's why you should assure. And an audit is just somebody coming in and checking whether what you did there is good or not. And DORA demands evidence. So DORA demands that somebody is doing that audit. Having said that, let's go back to the question how we do those 5-step thing. And as I said before, we do that by defining risks. What is a risk? Well, let's take one for example. A risk could be that my deployment of my service in Kubernetes, my microservice, might fail because the service is somehow unhealthy. Why could it be unhealthy? Well, for example, because the container crashes that my service is run with. Why would my container crash? Well, potentially because the node misbehaves that the container is running on. Why would a node misbehave? Maybe because the hardware glitches underneath it. Why would hardware glitch? Well, because the electronics that are actually inside the server somehow are not perfect. Why are electronics not perfect? Well, now we are at the material level in physics. Well, because materials themselves have limits, right? The silicon part that my transistor is built of might be broken somewhat. Shit. Now I'm sorry, excuse the language, but you might say now, shit, where do I need to go with this, right? I'm defining risks and I'm not sure where I actually should stop looking for a risk because that's infinite, right? I'm starting somewhere and I'm going from the single thing to an infinite number of possibilities why a risk should be a risk or not. That's actually very similar to this analogy of turtles all the way down. I don't know if you're familiar with that one, but Hindu mythology basically says that the world is resting on the shield of a giant turtle. Okay, let's take that. Then one might ask, okay, but what is the turtle sitting on? And then people would say, okay, that turtle is sitting on another turtle. Okay, but what is that turtle sitting on? Well, that turtle is sitting on another turtle. Okay, but and that, and so on, right? So you can see this is very similar to what we call in IT or in science infinite regress. What does that leave for me now for my problem with risks? Where do we stop looking for risks? Well, pretty easy actually. We stop looking at the point where an uncertainty no longer impacts margin. Or in other words, a risk is an uncertainty that matters, by David Hilson. Meaning, back to my deployment, I should probably make sure that my service is healthy, and I should also make sure that the node is healthy. If I'm start facing hardware issues, I should probably look into that. But most likely, I will not need to get an atomic force microscope and look at the silicon parts that my transistor is being built upon, right? Because that's not really something that matters to me. I should make sure that the things on a higher level matter, actually. That's only a short side note. Back to actually defining a risk now that we know we have to stop at some level doing that. A risk is not only a risk, but a risk actually consists of 4 things. We have a risk source, something that is the origin of a risk. We have a risk event, where something will actually happen. Then if that something actually happening is happening, something that might be at stake here, and we have consequences if that actually does happen. Again, very open texture. Let me put some texture to it. So a risk source might, for example, be, okay, we know there is an exploitable vulnerability in my container image, a CVE, right? A risk event would be, I'm deploying that image into my production environment. So suddenly I have a critical or high severity CVE in my production. That risk event does not mean that something will actually necessarily happen, but that risk event will give rise to the risk. The risk defined by that trident of information security, saying, if I have a CVE in production, I might have a system at risk of exposing confidential information, confidentiality. I might have my system at risk of executing actions incorrectly or being tampered with, integrity, or the thing becoming unavailable to users, CIA, right? That trident. And what's the consequence of all that? Well, to go back to DORA, we are breaching DORA Article 6, saying that we need to be resilient in terms of operational security. Okay, now we know what a risk is, and we have a concrete example for risk. Now we have to sit down and do all that for the 5 other steps I explained before. If I would do that now here together with you, we might sit here a while longer and not have time to finish the rest of the talk. And if we do that for our customers, it's usually a 2-day workshop where we explain them the whole thing. So I'm sparing you all that, and by the power of automation, I will just say 1 moment later, we have that picture, the whole story, right? Identifying a risk, defining a rule for it, verifying the rule is met, evaluating the result, acting on it. What does it mean in my story? We have the risk, CIA, as before, with the CVE in production. We have a control standard, so a rule how to handle that risk. The rule would say, in that case, production images must have 0 critical or high CVEs, according to DORA Article 6 and 10. The assurance procedure, how we call it, so verifying whether my rule is met or not, will actually check the CVE scan report we did, and it will prove that we actually looked into the CVE scan, right? So that we knew at the point where we were deploying that we actually have 0 CVEs in my production. Evaluating the result is actually what I already started explaining, meaning we make sure that once we go into production, we do not have any high or critical CVEs there. Otherwise, we will have failure. And the control procedure would then be, once that actually might happen, I will block my deployment, or once I realize I have something already running in production, I will trigger remediation. So make sure that this thing is no longer running in production. I hope that will now have given you some more texture on it, actually, right? So you can imagine something more concrete with it. The good news is we now know how to handle one risk for one DORA thing, say. The problem is there is more things than DORA. There is also SOC 2, there's ISO, there are internal policies. You know the story, right? There's a lot of things happening in reality. And the problem is, for all those audits, we need traceable, repeatable, provable evidence. Well, the reality, sadly, sometimes is that we know an audit is coming up, so everybody is running and panning around, trying to get documentation and proof for what we did over the last several years or months or whatever. And the auditor will do his field work to collect the evidence, but that's a tedious process, really. Especially if my number of deployments is really going up, right? My manual compliance capacity is actually really, really going down. That is the same story, by the way, as why we do these days automatic deployments to ensure standards, security, etc. Right? One of the reasons why such beautiful tools as Octopus Deploy really exist, because we cannot cope manually anymore with the thing we need to do here. And the same story goes for my compliance. So, meaning the actual problem is not the compliance itself. If we follow that 5-step process or any other process that we defined to make sure that we are DORA compliant, it's the problem to scale it up. And how about we then do some automation, right? As we did before in the past already with my deployments. And here comes a tool in we call NAPE, right? NAPE is doing automated assurance. NAPE is helping me to do all those things that I need to prove that I actually followed my own rules. That's where NAPE comes in. I will show you this still. This is basically the model that the creators of NAPE based the whole thing upon, right? You can see 2 parts of this image. Let's start at the top. The top describes things you already saw before in my 5-step process, right? We have controls and we have risks, and they correlate to each other, right? We have risks based with risk source and risk events, and we have controls to make sure we are handling those risks in some level. And as you can see indicated by the person on the right side of the picture, that's not something we can automate. We have to sit down and do the manual work of defining my risks and of defining my controls that I want to work with upon here. I also manually have to think about how I want to face those things, right? I will need to sit down and think myself on what would an insurance procedure actually look like. So how do I make sure that those things are checked, and what I need to do upon the control procedures, right? What would be actions I would have to take if my risk would happen, and so on and so on. But the good thing is, once I've thought of all that, and now we go to the bottom of the image, I can automate it. I can automate my assurance procedure using NAPE. That's the thing we will show in a second. And I can also automate control procedures, right? There is a lot of tools we can use for automating things we want to do. For example, Octopus Deploy. And for that matter, it's very important to state what actually NAPE does and what NAPE does not. NAPE does automated assurance. So NAPE proves that you actually do what you claim you do, but NAPE does not enforcement. NAPE does not enforce policies like things in the OPA universum or Caverno or anything else in that regards would do. So let me show you how NAPE actually does do that. I will switch over to my code and show you that NAPE actually is a tool we can use programmatically, right? If I wanted to do something in NAPE, I would sit down and write an assurance procedure. That assurance procedure would, for example, check that I have zero or no, that my check for 0 or no CVE scans was fine. Let's start here. Sorry, that's a better way to start. So what does NAPE need to prove that I'm actually doing the thing I'm doing? It needs evidence. What is evidence for that matter? Evidence would, for example, be that I have 0 open GitLab issues that describe open CVEs in my projects, right? So what do we need to do in order to collect that evidence? Well, we are just writing a short script here that will, as you can see here at the bottom, call the API of GitLab and just download all my issues that are open in my project, in my project code. Sorry. And the evidence would then look like this. Once I download it, I have a JSON file, and the JSON file says, okay, here's ID 745807, and that's a CVE, a medium CVE, and it describes it. And there is another CVE here somewhere, here, new medium CVE, and so on and so on. So I downloaded all my evidence. I have it laying here as a JSON file. The evidence shows what kind of CVEs I do have. Now NAPE describes in his assurance procedure manifest what I need to do, right? I want to check there are 0 high CVEs in my production environment. And how do I do that? I'm doing a test in the activity that says CVE no high.py. As you can see, that's actually a Python script. What does that Python script do? This Python script takes the evidence we took from before and checks whether in those incidents I have open are any high-level CVEs. And it does that by a very simple Python code, goes over all that, checks in the title, basically, if there are any high-level CVEs or not. And if you go further, we can also see in my insurance procedure here that I defined where my evidence should be, right? That's in that case, that CVE scan results I do have. And once I ran NAPE, I can show you what the output would like, and that's here basically. What I get is an insurance report. And the insurance report says, okay, we ran a assurance procedure, and that's the output of it. We have one activity, we have one action that ran, we have a CVE scan, check. We don't do a CVE scan here, but we checked the output of our CVE scan and said we have 0 matching issues found. So great. My assurance report says you actually did your CVE scan with a good result. And on the bottom, we see that my test files are here and my evidence file is here as well. So that's basically what Nape does on a CLI level. Going back to my presentation now, that's how you would call the CLI, right? First, we start the collection process. So we start the assurance session saying, okay, we want to do now that assurance procedure for CVE no high in production. That will create basically the folder structure we want. Then we will do the collecting of the real evidence by providing the file path to my actual scan result. And by the end, we will evaluate it, meaning we will write the assurance report that will do nothing but a binary pass or fail, right? It will say either it passed or it failed. Well, to be fully transparent, it can also be indecisive, right? There could be a result that says I'm not sure what's coming out, but in our case here we have a binary. We have 0 or 1. We pass it or we fail it. And then we will beautify the picture even more by saying, okay, we have automated assurance now by using my CLI tool, and now we will either block my deployment or trigger remediation. And that's where Octopus deployment comes into play, right? I don't need to justify here in that session why Octopus is great for automating all kinds of things, but I think the story becomes more complete by saying, okay, Octopus Deploy is actually the thing here in charge of the control procedure. Why does the combination work so great? Well, Octopus automates the when something needs to do, and Nape automates the proof. So together, we are actually building up a very nice scalable resilience for that fact. I want to show you all that in a demo scenario. And the demo scenario goes back to what we did before, right? We're looking at a risk event. That risk event would be that we deploy an image that contains a critical or a high severity CVE into production, and we want to deal with that. And if you've been in the session before by my colleague Dennis, this might look awfully familiar to you. So in Cross, we are living the scalability thing to the end. So we are using the same demo here because it proves actually that the two things that Dennis talked about and I talk about here are not two things that somehow are completely different, but it's different aspects of the same thing. So what do we have? We have at step 1 some code that is in a version control system, in this case GitLab. And we have Octopus deployment triggered by getting new code. At the second step, Octopus will run a CVE or GRE scan. And then after that, we will do, Octopus will run an insurance policy check. So Octopus will make sure by using Nape that we actually did our CVE GRE scan before, and that one actually turned out to be true. So we are not having any problems in our production environment. And how does Nape do that? Well, it collects all kind of evidence. In our case, it collects open incidents that we might have in the GitLab project. It could be also collecting CVEs that were found directly from dependency track or any other tool for that matter. I don't know, Harbor or any other tool that would run CVE scans, Trivy, think any tool in that matter. Or it could even be Octopus, right? It could be Octopus deploy job that produced some variables and output, and I could use that as evidence, right? The important thing is only Nape here runs my assurance policy check to make sure that we are doing what we claimed we're doing. And then we go into the direction of deployment with step 3. But if we fail our assurance policy check, then it's upon the user to decide whether we approve our deployment or if we say, nope, we're not going further here. However, if my assurance policy checks out, and that's hopefully the default case, then we skip that step, right? We don't need to manually ensure that this is good anymore because we have Nape being in control here and saying, all right, looks all fine, please proceed. Then we actually do the deployment into my OpenShift environment or wherever. And the last step in this demo here is that we commit the results to DevLake. Again, here the shout out to my colleague Dennis that presented just before me a session on what DevLake actually is and what DevLake does. I will not go into the details here, just so much. DevLake is a platform that actually helps you as a development team or the owner of a development team to get some metrics how you're actually performing, right? It will give you the DORA metrics, not to be confused with DORA the regulation, but DORA metrics. So how long your issues are open, how many issues you have, how long until a pull request is merged, how many open CVEs you have, how many GRC violations you have, etc., etc. So I will not show that here. And now I will actually start the video and show you that. So yes, here comes the video. So let me show you here. We are in NAPE. We have my project, and we will pause here for a second and show you the 4 deployment steps I have, right? So the first step is that we are doing, as I said before, the automated governance with NAPE, right? The next step, I will continue with the video. The next step is, oh, no, we're hanging. Okay, exactly. The next step basically shows the approval process and deployment. The third step will the actual deployment. And the last step will be to register all those metrics into my DevLake. So let's create a new release and let's try to deploy some code. We are deploying it directly to production. Of course, don't do that in a real case scenario. We're doing it here for the sake of the demo to keep it short. But you can see we are running a NAPE check, doing nothing but what I showed you before in the CLI. That will take a while now. You can see the output here of the whole thing. And if we look at the summary, we can see that my check was fine, right? We did not find any CVEs or whatever. That's why we approved or automatically the deployment already, and we deployed finally. And now we're sending over the metrics still to DevLake. So everything fine. That's the happy path to all that thing. Now, another very beautiful thing from Octopus will come into play, right? Octopus has also something like runbooks. Runbooks could be things that run on a regular base schedule. For example, my actual CVE scan could be in a runbook. So I'm continuously checking whether or not I do have CVEs in my images. That's happening here. Now triggered manually, but imagine that could be scheduled, right? On a daily or hourly base or whatever. And as you can see from the result, oops, we found CVEs. So look here we will pause here for a second. You can look here in my GitLab repository. You actually do see incidents, right? We have a bunch of CVEs found. Well, medium CVEs will always be there, but you can also see that we have a new critical CVE found that was not there before. Let me continue the video. So, yeah. So if I go back now and try to make a new release, hopefully that will fail, right? Because the NAPE assurance policy actually should not work anymore because we do have an open CVE. So we should not be allowed by our own defined policy that thing will run production. So now let's wait again and see what our deployment does. And you can see, oops, we have a failure, right? Great, we have a failure, one failure. And if we look in the actual output, we can see even from the code we have here, let me pause here for a second also. Never mind, sorry. Yeah, thank you. Yeah, exactly, that's what I meant. So you can see here I have a failure, right? One of my checks failed, and I even have my insurance report that shows, okay, the thing ran, but there is a failure, and I even have a link here. So if I continue my video from the demo and click here on the link, I will be forwarded to exactly that issue. So now let's pause for a second and let's think about how we would deal with those. Right. It could be, for example, that a CVE scan is a false positive. So I could do something to investigate that and then realize, okay, I don't need to deal with that anymore. Or it could also be that I need to fix actually something. In either way, there would be now a process that would look into that actual CVE and find a solution for it. I'm not demoing you here now how we fix the CVE. I will just assume that we now did the process of fixing that CVE and we can close the incident afterwards, right? Now we will continue with the video because you can see that I will now assign that here to me and say, okay, in that case, it was a false positive. So I will add here some notes saying, okay, the deployment is fine. There was a false positive CVE, not really of matter to me. So I will just proceed to deployment. And you can see that we will still have the deployment continue. And in just a second, that should actually have succeeded. Wait, I think I forgot. Oh, okay. It is deploying. Just takes a while. Yes. Okay. So now you can see we deployed, right? So we closed the incident. Nape was fine because it didn't find the CVE scan did not in the evidence there was no more open CVE in production. So Nape's assurance policy was fine and we're good with it. So let's pause here for a second. That's the DevLake environment that I will, as I said, not go into more detail here. If you are interested, I highly recommend that you, if you didn't before attend the session, that you go and check out then the session on that. But we can see here the GUI of my DevLake environment that ingested the data. Let's continue here for a second, also the video, and then we can see that the last step of my deployment actually triggered the ingestion of data into my DevLake scenario. That also takes a while to process it into the database. And once I have that, I can go here to my several dashboards I have. This is something that's more relevant now for the DORA part. But here, let's pause here for a second. You get here now the graphical overview of what kind of CVEs we do have or not have. And we can see we do have 3 open CVEs, but none of them is high or critical anymore. And that is a great thing, right? So deployment can walk through. And I even have here with DevLake the graphical overview, what is happening. Again, check that session to get more into that. Let's continue here now, our video. And yeah, I think that's about it. So that's the demo. Let me switch back to my presentation. So what's the benefit of doing that thing in Octopus Deploy in combination with Nape? Well, the actual benefit is that I get something like that on the right side. I mean, you saw that I actually had a YAML outcome that showed what's happening, but if I put just a bit more effort into it and a bit more automation, I can get a very nice, beautiful report that shows how my deployment at what day was good or bad, right? Just an example here on the right. And you can only go really fast in this today's world where you have something like DORA on the constant edge of being in your back by building compliant from the startup. I don't want to use the term compliant-driven development. Well, I kind of used it now, but you see where this is going, right? If you incorporate that from the beginning on, that kind of assurance reporting into your processes, you don't later have the panic coming up if an audit is approaching. Even more beautiful, if you have that kind of thing, you're 24/7 audit ready, right? That means if tomorrow somebody comes and says, hey, we are doing an audit, that's not a problem for you, because for all your 4,000 Octopus deployments you did in the past, you do have an assurance report. So you can just, if you want, print that or put it in one folder, give it to the auditor and say, here's your evidence, have fun. Have fun digging into it, and I can tell you for every tiny detail I did here that my story checks out, right? That I can prove you very, very beautiful that I'm actually doing what I'm claiming that I'm doing. Great. We have a good story here, I think. Let me just lose 2 words about the company I'm working for. Cross, we are a Croatian German BizTech consulting company. What does that mean? Well, we are not only doing all kinds of technical implementation things, but we are also asking the question, what's the added value for you into doing that? So we're trying to mix the business value of something with the newest bleeding technology at that point. And that means also if somebody comes to us and says, hey, I'm having compliance problems on the technical level because we don't know how to prove that we're actually doing what we're doing, we will try to take that story to the next level by asking, okay, have you actually considered from the top what your risks are and what your control standards are? So we can break that down from there until the very bottom into an actual technical requirement, adding texture to the thing, right? To take that up from the beginning. And our portfolio goes then really from doing strategic things by change management, innovation process, value stream management, that the kind of considerations we did now in our situation here in regards to what actual risks and control standards are, over engineering, so basically building the thing, and we go here from actual really mainframe legacy old school things, more relevant than ever, up to using all kinds of AI things and cloud things. Not losing too much time here. And also we are then helping you to put the whole thing in operation. So we have that the triangle of the whole thing here. So to sum up what I spoke about today, and to take that dog statement from the beginning, like dogs have to be under control, in summary, that means basically DORA would state your dog must be controlled. We as human beings would specify the leash. Nape would check that we actually do use the leash, and Octopus would stop the dog from bolting. With that, thank you very much.
Awesome stuff. Thank you very much. Great talk by Bernie, and great talk by Dennis. Bernie is actually here joining me. I'll go ahead and add him to the stage. How are you, sir? Nice to see you.
Hello.
We actually recorded this session because you guys were busy, you had work commitments, etc., but you jumped on here to answer any questions. Wanted to provide some folks some context, excuse me. Bill was actually kind enough to provide us with a link there to some resources that you can check out, and you can find these at napecentral.com/resources. Thank you, Bill. Really appreciate that. We had a few comments from Bill there, so cheers for that. Yeah, so great talk. Sorry, was there anything you wanted to add to that?
No, I was going to say, by the power of automation, I cut my hair and changed my shirt.
That's right.
Yeah. Thanks. It's great for having me, and thanks to Bill also for stepping in here and answering questions already. And I can only highly recommend checking out those things. They're nicely documented, and there's all those examples actually do have a lot of texture to them, right? So you can already grasp the thing without having too much to deal with too much open texture. But yeah,
are you guys applying that like consistently across all your projects at Cross?
We do try so. I mean, it really depends to the customer, right? Because the customer is paying the bill at the end, meaning in the total end, the customer also has the power of saying what's in or not. But yes. If we are able to make a suggestion, we do really recommend doing it, right? I mean, we have DORA coming in Germany, at least, getting sharp or trigger ready by next year. And then from what we see, a lot of people will actually run into issues and run into panic mode. So we're trying to prepare people already now by being audit ready from the beginning.
So to educate folks about DORA, the DORA regulation that's coming into Europe, obviously, this is something that everyone in Europe is thinking about, but maybe the folks in North America may not be aware of that. They're thinking DORA, that thing that Google started. I mean, it's an unfortunate collision of names there, but can you tell folks a little bit about that?
About the DORA per se, well, it's this Digital Operation Resilience Act. It means basically that more or less all, with some extent, highly regulated businesses, banks, insurance companies, fintech per se, has to follow along and provide that frame, right? And that means you have to be ready for an DORA audit when it comes to you. And there are fines actually if you are not DORA compliant. So it's not actually. What we do see is that a lot of people that were hesitant in the past to spend money because they said we are not really seeing added value by spending money, are now trying to spend money in order to avoid fines. right? So
It's human
it's maybe
nature. We
the
do
wrong-
everything at the last minute. Come on.
yeah. I mean, I'm not complaining, right? I have my bill paid, but yeah, we actually see that as a business driver here currently. So it's definitely a hot topic. Yeah.
Yeah, awesome. Well, if you guys want to find out more about CRAWS, you want to learn more about, obviously, compliance to DORA, etc., you can check them out at craws.net, I believe is the website.
Yes.
Dennis, thank you. Bernie, thank you. And thank you for speaking at SHIPPED. We really appreciate it.
Thank you so much for having us. It was great fun.
All the best. All right, so moving right along, let's take a look at our schedule here. And thanks to everyone in the chat. Really appreciate it. Don't forget, we're monitoring the chat throughout. If you have any questions, feel free to submit a question or a comment. We love comments too. So coming up next, we're going to talk a little bit about community at Octopus Deploy. This is something that I think a lot of folks may not realize. We actually spend a lot of time doing things in the community. We spend time at events. We were recently at AWS reInvent, which is like the biggest conference ever. We were at GitHub Universe. We were at KubeCon, etc. And so I thought it would be fun right now to share a little bit of context there about some of the things that we saw along the way. This is not only for events at KubeCon in Atlanta, but also other events that we do on a smaller basis, namely something like, say, in Perth. How's it going? Hi, folks. We're here in front of Optus Stadium. This is my first time to Optus Stadium. Matt, how about you?
Yep, first time Perth, first time Optus Stadium. I've watched many a football game here from the TV, but not been here in person. So.
Awesome. Well, we're here to attend DDD Perth. This is a yearly event that the fine folks here in Perth have been running, and we're going to be attending some sessions. Anything you're looking forward to?
There's a lot of sessions on the agenda. I don't know if we'll have time to get into many, but I'm hoping to sneak into a few. Might have to just sit at the back and have a look, but there's like 4 or 5 different tracks. There's a lot of content here today, which I was actually pretty surprised about. So that's really cool. Yeah.
Awesome stuff. Well, let's go inside and take a look. We're going around, we're asking people some questions. They're very easy, don't worry. Multiple choice, so no pressure. So we're going to start off with an easy one. The question is, which stage usually, not always, but usually comes first in a pipeline? Is it A, build, B, test, or C, deploy?
Usually build.
Usually build?
Yes.
Okay,
Yeah.
very good.
I heard it, he said build, but yeah, definitely build.
You sure? Final answer?
Yes.
Okay, lock it in. What do you think is build? There. Oh, look at this guy. He's kicking goals already. I'm going to use a lot of metaphors for you. Man from Melbourne, knows what he wants, dressed for business, working like business. Awesome. What is the first step, do you think, for a pipeline? Is it build, test, or deploy? Build. All right, very good.
Test.
Test. Why do you say that?
We need to do some unit tests before.
Oh, you're a test-driven developer, aren't you? TDD. Okay.
Have you written any YAML before? Have you worked with YAML?
Sorry, I don't know about this part.
Do you know what YAML is, sir?
No.
No. Do you know what YAML stands for? Have you heard of YAML before?
Yes, it's kind of format. It's complete stuff.
Correct. So you use it for workflows, things like that. What do you
Yes.
think the term YAML stands for?
I don't know.
Okay.
It's quite funny because we've actually made YAML engines before.
Okay.
And so, but I think obviously, I don't know. I guess yet another markup language, but I know there's like another subsequent after that. It's just like, no, it's not, or whatever.
You are my
Life.
Life.
Hey, I like it. All right.
Cheers.
Life.
I'm going to go with the last one, yet another markup language.
Okay, very cool. Yep, well done.
So the CI in the term CI/CD, what does that stand for?
Integration.
Continuous integration. Okay, look at this guy, right? All right.
Continuous integration.
That's correct.
It's like continue improvement or continue integration. Sorry. Yeah.
Yep, I was going to give you some options, but I think you've nailed that one. So, yeah, great work.
Continuous integration.
Amazing. Look at that. We didn't even have to give off any multiple choice options. So, fantastic. Yeah.
Agile web dev, you know?
Yeah, that's right. Yep.
That's correct.
Continuous integration and continuous deployment.
Excellent. He's already answered the question. I didn't even have to ask it. It was, what does CI stand for? So, look at that. You already know and you're all over it. So, yeah, awesome stuff.
All right, we're here at DDD Perth. We are here with
Ben Walker.
Ben, what do you do?
I'm a data engineer at Octopus.
All right, cool. What does that entail?
Gotta say data engineering things. So taking data in its rawest, transforming it, and giving it some business context. So,
very nice. Very nice. How are you enjoying DDD Perth? Is all right?
Really good. Yeah, lots of people. Big turnout. It's nice to see some familiar faces as well. So.
Hello.
Hello.
You can just hold it if you want.
I'll just hold it. Hello.
How's it going?
Good.
Who are you?
My name is Mandy.
And Mandy, what do you do at Octopus?
I work in the front-end foundations team. We do the design system and the front-end architecture of the app.
So you guys get all the cool pixels to manage.
That's right, yes. Yeah, and the state and all of that front-endy stuff.
Awesome. And what sort of languages do you use?
We have React,
okay.
TypeScript.
Yes.
That's CSS, HTML.
Sure. That's like saying you use butter to bake.
Yeah.
All right. I found another Octonaut. Who are you?
Jared.
And Jared, what do you do at Octopus?
Was a data engineer now.
What happened there?
Half a data engineer, half a data engineer now, but a bit more in the engineering management space now. But I still love getting on the data tools.
Well, what's your favorite thing so far about DDD Perth?
I think it's probably the community. Yeah, it's good to get everyone together. From all different kind of backgrounds, different disciplines in kind of software engineering. Space, so
so tell us a little bit about Perth, how long you lived here, etc.
I've lived in Perth my whole life.
Okay.
I love Perth. It's like all the benefits of a big city, but it's like super chill and relaxed.
Okay.
We have great weather, good beaches, and quokkas, the happiest animal on earth.
Describe a quokka to someone who doesn't know what a quokka is.
Quokka is a marsupial, and if you Google it, you'll know why. They're so cute. They look like they're smiling and happy all the time, and they're only found on an island off the coast of Western Australia called Rottnest.
Streaming, and then Tableau sitting on the top of the stack for reporting as well.
So are you guys data guys? You just sit around and cook up queries, and you're in the shower, you're walking the dog, you're mowing the lawn, you're just thinking of T-SQL and queries all the time. Is that all you?
Yeah.
I thought so.
Big dirty long CTEs. Thinking about data. Going into every single.
Man, if we could just normalize everything, life would be simpler. You see everything. You're like, we could normalize it all.
But just ask AI these days.
Yeah. Okay.
Right?
Fair enough. And if there was a feature of Octopus that someone could point at that you said you did a lot of work on, what would it be? Anything recent? We got the new process editor, for example.
Actually, our team did help build the front end for the process editor.
Nice.
Specifically. We helped build that.
Any challenges you had to overcome with that?
Not particularly, no. Okay. We worked with one of the other teams at Octopus, and they did such a great job. It was very good, smooth process. They were fun to work with.
Well, Matt, there's another DDD Perth done and dusted. What were your thoughts?
It was a fantastic day. It was a busy day, wasn't it? Lots of people, which was really good to see, especially on a Saturday. Lots of people out for it. And what surprised me a lot, even though I was warned about it, well, not warned, that's the wrong word, but was that there's a lot of people from different backgrounds. Yes. I spoke to people in data, I spoke to people in product, I spoke to people who were, of course, software devs, but we just had a bit of everything. I was chatting to a guy who was doing hardware stuff and actually, doing electrical engineering. Just an awesome range of people. Lots of fantastic sessions, heaps of people and customers by the booth, wasn't there? So it was really cool to see that.
Yeah, it was good to chat with people hanging out here at the Optus Stadium. Very cool venue here, and quite impressed actually with all the facilities. And like most developer events, lots of really cool people to talk to. So Yeah, so on behalf of myself and all of us at Octopus Deploy and Matt over here, man of many words, obviously happy deployments. It was great to see you all at DD Perth. We'll see you on the next one. Take care.
Coming! Don't worry. I spent all last week tracking down our compliance documentation. It's all right here. Sorry, I need something.
Talk about the migration of the two.
Sorry, everyone. Sorry. Really important thing. What are they? Except for the deployment records. Quick, bar the doors.
Are they okay?
Oh yeah, they're fine. Everything you need is here in Octopus. Octopus logs all activity in every deployment, so it's instantly auditable.
That seems perfect.
Octopus. Pass audits without the scramble.
Who have I got here? Who are you? What do you do?
Shannon Russell. Yeah, Shannon Russell, thanks. I'm an account executive here at Octopus Deploy.
I found someone else. I found another victim. Michael, how you going?
I'm very well. How are you?
I'm doing well. All right, I've gone and found another dangerous Octonaut.
Yep.
Liam.
I'm Australian, so I'm definitely dangerous.
How you doing?
Good, how are you?
I'm good. All right, so I've gone and found another Octonaut here. Sean, how you doing, mate?
Doing pretty good. How about yourself?
Yeah, I'm doing well. Robert, I found you again. How you going?
Good. It's been busy.
Yeah.
Feet hurting, voice is getting sore talking to everyone. But it's been good.
That's the way.
It's been really exciting, crazy, busy, chaotic, but in a good way.
Day 3?
Day 3 now.
Yeah.
Voice is holding up though. I can still speak.
Yep. How are the feet? Are they all right?
Feet are a little bit sore.
Yep.
But, enjoying it.
How's the week been here, Coupon? Your feet holding up
It's
all right?
been good. I'm holding up. My social battery is at like a 75 today, down from 100% yesterday. It was very busy in the booth yesterday, but it's been fun. It's been really good. We've had a very busy booth, very busy start to the week.
I took painkillers first thing this morning.
100%. I've seen you standing here all day on the demos. So how's it been going?
It's actually been going really good. The two things that have landed really well, Argo City and Octopus, with the environmental progression.
Yep.
And platform hub.
Yep.
Almost everybody I've talked to about it are like, yep, that makes sense, and I want that.
How many KubeCons you been to?
Oh, what is this? I think this is 4th.
This is the 3rd, I think.
Okay.
They kind of get bigger and bigger every year, I think, which is a sign of what's happening in this part of the industry.
This will be my 3rd.
3rd. Okay. Awesome. Good stuff.
A lot of excitement. I know that's probably your next question. What are people asking about? They're really excited about Argo and Octopus. The live demos every 30 minutes. And I've had a lot of customers that immediately want to go see the product live in action with Bob or Ryan. So it's been good.
Yep. These guys on the side on the demos have been on it like
Rock
all day.
stars.
Yeah. They're holding up, and we've got the sessions out the back as well every 30 minutes, which have been really popular as well.
They've been a hit.
Oh, look, it's at this event, it's definitely Argo and Platform Hub, and the combination of the two, it's a great story to tell. Feature-wise, I feel like Octopus is really feature complete for this scenario now. It's landing well. We've got a good answer for most of the questions we get asked.
Yep.
So it's really fun. Watching the story change over the years with the KubeCons has been really amazing.
It's all about Argo. I mean, although Argo hasn't necessarily kind of completely won and over-dominated how people are deploying to Kubernetes, it still seems like it's the common thing that people are thinking about.
Yep.
Sometimes customers who aren't yet using it are aware of it and starting to play around with it. So it's really nice that now in Octopus we've got that integration that can solve some of those problems that they've got as well.
I would say I feel like Kubernetes has hit its plateau, if you like, at this point. I feel like it's not the new thing anymore. It's just part of the landscape now, and it's reached the top of the adoption curve, maybe. And
just the standard platform that we're deploying
the standard platform now. Yeah, I think some of that kind of hype has worn off a little bit. I mean, the other thing is the AI theme. Every single booth has AI on it to the point it doesn't mean anything.
Yeah, that's right. Yeah.
If I hear the word agentic once more, I'm
yep.
going to flip out.
Dag, is your buzzer broken? It works. Okay.
Now, I'm tracking down everyone that's got a session this week, and I've heard that you, on Wednesday, are talking to people about Kubernetes.
Well, specifically about performance in Kubernetes and how to design applications that actually perform well.
Okay.
When you're using Kubernetes. Diagnosing application performance using eBPF, Gyroscope, and Kubernetes. If that sounds like a bunch of buzzwords to you, you should definitely come and learn.
This is based on real-world stuff that you've been involved in, right?
Yeah. This is based on real-world experiences with Monitor and how we made sure that it was performant for customers from small to large, from not crazy to very crazy.
Yep. Awesome. I love it. You've got a session later today. I've seen it. What's it about?
It's about feature toggles and deprecations. Now, a lot of people are used to using feature toggles to add features. Not a lot of people use it to deprecate features, and really removing code is, for me, the most fun about being an engineer, but also it's one of the most important things you can do to keep your system safe and kept up to date. And feature toggles are a really great way of helping you to do that.
Yeah, you're quite right. It's always turn on the feature toggle for a new feature, but what happens when you've rolled out 10, 20, 50 and 100 features? Where does that leave you?
That's right. It's the same sort of risks are involved and the same sort of worries that people have when they're adding features, but we don't really think about that when we're removing features. So yeah, talking about some of the tips on how to use feature toggles for that. And going through a bunch of scenarios and experiences that we've had at Octopus of deprecating features and talking about how successful it's been.
Yep, awesome.
It looks a bit like Argo CD, right? I've got application tiles, I can see my source of truth, I can look at my application.
It's going to be changing that replica field, and Argo CD is going to look at that and it's going to say, hey, that's supposed to be this number in Git, and if you have self-heal turned on, it's going to go and overwrite that.
So a very simple example is when a team adopts Argo CD, you have to answer the basic question: do you want an Argo CD per cluster, or you want a central Argo CD instance that controls other clusters? And you can also get some control planes from...
Are we both in the frame?
Come on, Colin, come on.
Whack that on. Flip that on. Yeah.
Awesome stuff. Really great to see all the community involvement. It's always great to connect with all of you as part of the community, and I can't tell you how much fun we've had over the last year, and this is just a culmination, this event shipped, of all that involvement. So great stuff there. All right, taking a look again at the schedule. We are forging ahead here on day 2, which is wonderful. We have a small break. Congratulations, we made it to a break. Coming up next, Rahani is going to do a quick talk here on feature flags, dark launches, and safe deployments, reducing risk in production. And then we'll have Felix and Eric and a whole bunch of other stuff. But for now, feel free to stretch your legs. We'll be back here in approximately 10 minutes or less. We'll see you soon. I was just, oh, all right, we are back. Apologies for that. I keep tripping over the fact that I'm muting myself and then I forget to unmute. I apologize for that. All right, let's take a look at our schedule just to remind folks. Coming up next, we've got Rajni, who's obviously corrected me on the pronunciation. I am so sorry about that pronunciation. Who's going to provide us with a talk entitled Feature Flags, Dark Launches, and Safe Deployments, Reducing Risk in Production. I'll go ahead and add Rajni to the stage now. Welcome. How are you? Oh,
yeah.
There you go.
Hey,
hi.
You? Hi.
I'm well, thank you. Thank you for speaking here at SHIPPED. We really appreciate it. Why don't you tell the folks a little bit about yourself?
Yeah, can I just share my screen and start because I have a dedicated slide from my intro there?
Sure, no problem. Here you go.
Yeah.
Oh, and you can, yeah, switch screens. There you go.
Yeah.
Perfect.
Okay. So hey guys, so my name is Rajni Ekunde, and I'll be talking on, as John introduced the topic, so I'll be talking about feature flags, dark launches, and safe deployments, like using these all things, how we can reduce the risk in production. So this is basically the topic is, and we'll be discussing a lot of things around the same. And this is all about me. Okay, so currently I'm working with Okta as a senior site reliability engineer. I have joined them recently, like it's been just 4 months, I guess. And I'm a Docker captain as well. and a WTO ambassador as well, where we basically try to include more women into tech conferences and into tech basically. And I'm an international speaker and a Lyft scholar as well. And apart from the day-to-day activities that I do in my work, so I really love enjoying writing technical blogs, and I'm very active in the cloud and DevOps community. So I basically believe in how I can give back to the community. So all the things that I have learned, I believe that I have learned from the community only. So I just always look forward to any opportunity where I can basically give back. So that's all about me. So let's jump into the topic that we are having. Okay. So why exactly this topic is important? Okay. So I had given I guess 3 or 4 topics, but out of that, John told me like you just need to come up with one topic which is gonna be the best one, like which I'll prefer. So basically, that's how we ended up with this particular topic. So why exactly this topic is important? We'll talk about that. So before actually we are getting into the tools and the techniques of the thing, I basically would love to start with why exactly this is important. So if you are seeing an example on the slide, so you can see there's an example I have mentioned in the slide. So there can be a single unnoticed feature that can broke your entire infrastructure for 30% for the users. Okay. And that is really gonna be a very scary part, because considering you are dealing with a payment system, and if you notice that there is some issue which is causing you 30% of the users, so this is really very scary. And suppose if you have already like deployed the code globally, and like for example, like take into consideration that there was no feature flag included, and there was no OIS solution provided, and there was no kind of any kind of dark testing was done. So this is the scenario that you are having, and by the time you and your team is realizing the issue, uh, like rolling back to the previous stable version of the deployment is going to be really taking a lot of time. So this is what the situation is. And honestly, this is not uncommon, I'll say. So I have seen like something similar to myself when I was working with my previous organization. So there was a very tiny backend logic that basically changed silently, and it impacted around 10 to 15% of the sessions. So that happened, and eventually everything, like the testing and stuff, that all passed, but everything looked very perfect. But when we noticed the production, so that was a completely different scenario. And once everything was live, so we basically lost the control. So that's was one of the scenario that I had faced. And like this is basically where your mindset should shift, and that is very important, because when we are talking about safe deployments, are safe deployment won't mean like kind of a slow deployment. Okay. Safe deployment will always allow you to ship in a very fast manner with confidence as well, and basically by providing you high availability and stability as well. So this is how this is important. And if we are talking about some okay, so the most of the mature engineering teams I have seen, so they mostly don't rely on luck. So of course this is a good practice, like we shouldn't rely on luck. So these teams, or we should always use these different terms, different things we are having, like feature flags. We do have dark launches, we do have canaries, we do have progressive delivery things. So multiple things are available in the market, so we can of course make use of this, and we can try focusing how we can basically stabilize the production, and we can provide high availability to all the end users. So this should be the end goal. And this is the reason why this particular topic is very important, and why we basically chose to go ahead with this topic. Okay. So next up, we are having what exactly the problem that we are facing, or what is the problem which we are trying to solve here. So I do have multiple bullet points mentioned on the slide here. Okay, so we'll just talk about these all one by one. So firstly, when we are talking about safe deployments, okay, so that is because of these traditional approaches. So if we are going ahead with the traditional approaches, so simply like in most of the cases, or in some cases, we can see that traditional approaches won't work. So this is the first issue, that we can call as deploy and pray. So this is the mentality we are having when we are dealing with the traditional approaches. So in this, you just don't deploy something and you hope nothing should break. So this is how basically it's all based on the luck. So if we are going ahead with this particular mentality, then of course there won't be any kind of safety, or no gradual rollouts are going to be there, or no backstop is going to be there. So this is one problem that we are having. Another challenge we do have is big bang releases. So if you are considering that you should ship 10 to 20 changes at one time, and when something is going to break, so you need to like basically go ahead and dig deeper, like what exactly is the issue, what is the reason that this particular thing failed. So this is the scenario. And even if it's looking like there are like 5 multiple dishes are there in one particular plate, and then you are trying to test which ingredient ruined the flavor. So this is basically very complex, and it's definitely going to take a lot of time for you to debug that. So this is another problem we are having with big bang releases. Then another we have is tight coupling between your deployments and the releases. So the moment you are gonna basically deploy, the feature is gonna go live. So that's the scenario, and there won't be any kind of space to test your changes or test your features safely, and there won't be any kind of opportunity given to you so that you can expose the thing slowly. So this is another issue we are having, okay, which is basically of a tight coupling between the releases and the deployments. Another problem we do have here is of hard rollbacks. Okay, so anyone who has ever been part of some kind of emergency rollbacks, we can say, so they should know how stressful it is to like basically perform a rollback, a complete rollback in an hustle or in emergency situation. So it's going to be very slow, and sometimes it can be incomplete as well. And this hard rollbacks can often like basically result into riskier than the usual deployments that we are doing. This is another issue. And next we do have is no control over the live traffic. So you can't say that like a thing like let me just first test this, and then let me just test this with only 1% of the users, and it's all or nothing. So this is another issue we are having. So we won't be having any control over the live traffic that is flowing to your product. And then finally, we do have another issue that is of poor visibility into the real time. Okay, so by the time you are realizing something is wrong, something is broken, end users or customers, they have already felt the impact. So this is another issue. And these are multiple pain points. Basically, they are trying to tell us that we need better strategies. Okay, so strategies which should give us flexibility, control, and safety, and good performance, high availability. So multiple things are there expected by the end users, and we should be following such strategies which are basically giving good experience to the end users. So this is the problem that we are trying to solve here. Okay, so next up we are having what safe deployment space actually looks like. Okay, so again, I have mentioned multiple points here. Okay, so first we can see here is deploy anytime. Okay, so deploy anytime doesn't matter if even if it's like 11 a.m. in the morning, or it's 7 or 8 p.m. at night. So deployment no longer means everyone sees the feature. Okay, so you are basically shipping the code, and you are not releasing the functionality. So this is how deploy anytime thing should work. Then we do have release when ready. Okay, so there can be a scenario that maybe your business wants to announce like some feature or some product next week. So or maybe your like quality automation team wants some more testing to be performed. So in this aspect, like your deployment and your release becomes two independent decisions. So this is another safe approach that we should follow. Then again, we can talk about instant rollbacks as well. So if the feature is causing some issues, okay, so there won't be any need for you to like you don't need to redeploy or rerun the pipelines. So you can simply go ahead and you can turn it off, and you can imagine basically simply like doing an undo button in the production. So that's how instant rollback should be working. Then we are having the like a control over like your audience. Okay, not over the audience, but control per user, or control over the audience. So you can basically start with your internal testers, and then maybe like 1%, or then you can go ahead with the 5%. Like gradually you can increase the confidence, and then you can test your updated changes. Then again, we can talk about one more, one of the like biggest superpowers we can say that basically is experimenting safely in the production. So this is like very important thing, and very kind of highlighted thing we do have, like directly testing in the production, or performing any kind of experiments live in the production. So you just basically you can test your backend performances, and you can see your how exactly your UI is flowing, and you can basically deal with some kind of new logic. Basically we can talk about real users, or like the live traffic that you are facing, but you are doing these all things in a controlled exposure. So that is how you should basically experiment safely in the production. And then again, we do have last point here as observe, measure, and adjust. So this is the process, or this is the loop that basically we need to follow. We first need to observe, then we need to measure, and then we need to adjust the changes. So this is how safe deployment should look like. So in short, like if I'm summarizing this slide in one line, I can say that it's basically like you are driving a car, and you are constantly looking at your mirrors, and you are making the small adjustments, whether you are properly able to see which vehicle is behind, or on your right side, your left side. So you're constantly making the tiny adjustments on your mirrors, and that's how these safe deployments are going to give you the exact same ability which your mirrors are giving you. So that is how your safe deployment should look like. Okay, so this was all about the slide. Okay, so let's now get into one of the point that I had in the title of this topic, that is feature flags. So we'll be understanding what exactly feature flags are, and some more components, or like some more features of the same. So we'll go ahead with one by one, whatever different points I have specified here. So feature flags are like we can say that they are one of the simplest yet most powerful tools for your safe deployments. Okay, and the core idea of feature flags is basically you can deploy your code anytime, and you can decide separately when your users should actually see the feature. So this is very interesting. Like at least I found it very interesting. Like you can basically deploy your code, but you have the freedom to decide when your user should actually see the feature. And this scenario, or these feature flags, they completely change how your teams are working. And talking about one of the like benefit of feature flags is decoupling from your releases. So you can basically push your code into the production, and you can let it sit there quietly for some time, and then you can reveal it only when it's truly ready. So this again is going to give you the complete freedom, or complete complete freedom to like do what basically when you want your users to see the feature. So this is how complete ownership, sorry, I was not getting that word. So you'll be having a complete ownership on your code. So this is another benefit we do have. And another one of the major advantage I can see here is that when it comes to environment specific toggling, so that is again possible here. Like you can turn one flag on, like basically on in dev environment, and you can basically turn one flag off in staging environment. So this on is basically going to be dealing with the internal users in the production, and the off is basically for the external users. So that is how you can toggle between on and off for these different flags that you're using. And this all functionality you'll be doing without touching the code or without performing any kind of redeploying of the actual code base. So this is very big advantage that feature flags are providing us. And there are again like some kind of more things I can talk about here is we have this concept of granular rollouts again. Okay, so simply you can say that if your requirement says that you just need to show this particular new feature to only 5% of the users, or you are basically like you want to show this particular feature to like only, we can, for example, we can take only Bangalore based users, or you want to show this to only premium customers or premium users, or only internal team members. So you'll be having this like you can choose what exactly you want to do with the customers or video or with the features. So this again is going to give you an like incredible control. And again, like suppose of course if there is something which is failing, okay, so if something fails, something is breaking down, then again rolling back to the previous stable version is going to be really very quick. That's going to be really very instant. You just need to turn the flag off, and there won't be any kind of downtime going to be there. So this process is going to be very instant. And flags again are going to make your deployments very safe, and the experimentation process is going to be very easy, and the debugging is going to be very fast. And it's simply like you'll be having the remote controls for your own software, and again the complete ownership and the complete freedom. So this is all about feature flags for not one. But apart from this also, like that, there are many different things, many different features which feature flags are providing. I have just tried to summarize like the most important ones here. So next slide, we do have what different types of feature flags are available in the market. So the most common type we have here is the release flags. Okay, so these release flags are basically going to help you to ship any new features in a gradual manner. Okay, so instead of exposing a really big UI to redesign to everyone, you can basically start with a very small percentage of the same. It's basically like testing a completely new dish in a completely new restaurant, only with like limited amount or only with few customers before putting that particular dish onto the menu. So this is basically how this release flags are working. Gradual rollouts is going to be provided here. Then we do have experimentation flags as a second type. So this is basically A/B testing toggles, we can say. Okay, so this experimentation flags are going to allow you to expose two variations of the same feature to different user groups. And you can again imagine like you have a version A of your home screen to one group, and you have your version B to another group. So whichever performance is going to be better. So this is how you can basically improve the conversion rates. So this is how this second type is working. Then we do have ops flags. Okay, so these ops flags are mostly used as kill switches. Okay, so these becomes very handy when you are dealing with incidents. So if a new recommendation engine is kind of misbehaving, or it's not working fine, or you are basically having a new cache layer that is causing some kind of overload or burden, so you don't wait for redeployments. So you simply need to switch it off. And I have seen outages which basically help you to prevent purely because of a kill switch was existed. So in these cases, ops flags are going to be playing a really important role. And then we do have one more type here, that is permission flags. Okay, so these flags are going to help you to restrict the access based on different roles. Okay, so it's more like enabling a premium dashboard only for the paid customers. So, or in other terms, we can say that it's similar like you are basically exposing the beta features only to the internal staff. So that is how permission flags are working. So each flag that we do have here in feature flags is going to help your teams to release in a very smart manner, and you can basically go ahead and test in a very fast way, and you can again recover quickly as a rollback is very instant here. So these are multiple feature flags types we are having. We do have a very short demo as well. So we are going to get into that as well once I'm done with explaining these things. So next slide we do have is about dark launches. So I do have here the definition, use cases, and one of the examples as well. So we'll just talk about these things. So talking about dark launches, so these are nothing but I can say that dark launches are the most underrated deployment strategies. So the idea here is basically very simple. Okay, so you can deploy your new code to production, but you can keep it invisible to the users. Okay, you can deploy it, but keeping the code, keeping the deployment invisible to the users. That is possible using dark launches. So it's more like you are installing a brand new engine in your car, but you're keeping the car inside the garage for your internal testing. So in similar manner, dark launches are gonna work. So one huge benefit we do have here is the backend performance validation we are having. Okay, so no staging environment is truly gonna reflect the real production traffic patterns. So these dark launches are basically gonna allow you to run the code under the actual load without taking any kind of user risk. You can perform the testing, but there won't be any kind of risk involved in the same. So this is incredibly powerful for features like when it comes to recommendation engines, or you are dealing with the payment pipelines, or we can also take an example for the search algorithms as well. So in these kind of use cases, this is going to be really very important. And another great use case we can talk about here is API first development we are having. Okay, so your backend teams can basically release they can release and they can validate their APIs before your front end team is going to start using the same. So this is again possible only because we do have this use case, API first development, and there won't be any kind of waiting, or there won't be any kind of dependency blocks as well. So this is the second use case. Then we do have dark launches, like the third use case basically. So dark launches again are very useful for validating the infrastructure at a scale. So it can be the scenario that maybe you are switching to a completely new database, or you are basically incorporating a new caching layer. So you can start the routing in real time traffic in internal way, and you can basically observe how exactly things are working, how exactly the infrastructure is behaving, or the setup is behaving, and then you can make the adjustments long before your users can actually see it, or your users can actually use the same. So that is how, again, another use case we are having for dark launches here. And like summarizing this all slide into one line, we can talk that we can take an example. Okay, so one of the best example of the industry is basically the like button of Facebook. We do have, like, I'm not sure like how many people use Facebook here, but still. So we do have this like button on Facebook. On every post we do have this. So these like buttons are dark launched. Okay, so suppose if they dark launched it for weeks before rolling it out publicly, so they can basically test the performance, they can check the stability, they can check the behavior. So basically we can check everything that is going to happen, but that is basically kind of acting behind the scenes. So that is how dark launches, that is basically what dark launches are and what different use cases it is supporting. Okay, so another slide we do have here is for canary deployment. So this is again a really very interesting concept we do have. So canary deployments is taking an inspiration from like we can say we have this mining techniques, okay, old mining techniques. So that from there this inspiration was taken for creation of canary deployments. Okay, so if you have seen, miners used to carry these different canaries into mines because the birds would censor the danger before the humans did. Of course, that's a fact. So in technology, a canary deployment is it's basically your early warning system, we can say. Okay, so it's basically going to give you a warning if something is going to happen, something is major is going to happen. So instead of So instead of releasing a new version to 100% of the customers or the users, you can basically start with a very tiny percentage. So maybe it can be 1%, or it can be 5%, or it can be 10%. So based on how exactly you want to test, or how exactly your metrics are looking, so based on that, you can basically increase the number of customers. So that is how canary deployments are working. So we can basically try taking in practical example here. Okay, so imagine you are upgrading your payment microservices, and instead of exposing every user to the new version, you can send the traffic from only 1% of the users. And if something is going to break, you can say like there is some kind of error spikes are there, or there is some kind of latency issues are arising. So you can basically observe what happened with 1% of the users, and then you can basically like tell your system to automatically roll back to the previous stable version. So this is how we can basically experiment with only a tiny number of people, and then you can go ahead with a big number of people. So this approach is very useful for infrastructure changes, I can say. And again, if you have to do some kind of risky backend updates, so in that use case, again, like this canary deployments are going to play a very important role. And canaries again are going to give you real production insights as well, even with very minimal risk. So you don't have to guess, you just have to observe things. And again, like there won't be any kind of thing like we are hoping, or we are dependent on the luck. So there won't be any such scene. You just need to observe the scenario, and you just need to see the metrics, the measures, and based on that, you can either roll back or you can go ahead with the deployment. So that is what exactly canary deployments are, and how exactly they're helping us to like basically improve the deployment strategies. Okay, so again, blue-green deployment. So this is again a very interesting concept we do have, that is blue-green deployment. So blue-green deployment are one of the I can say they are one of the cleanest ways to ship your big releases without any kind of downtime. So you can think of blue-green deployment as like having two identical houses, and one house is basically you are living in, that is, we can say that is a blue house, and one house you are having, that is a greenhouse, but basically you are renovating the same greenhouse. So once the renovation is perfect, you can move in from blue house to the red house. So that is how this process is going to be again very instant. So this is what exactly blue-green deployment is. So if we are basically talking about how this we can relate with the production environment now. So in production, we can consider that blue is your current live environment we are having, and green is a new version that is being prepared. Basically, you are renovating, and like based on the traffic that is continuously flowing into your blue environment, your green is going to basically sit idle. And once you are pretty confident that like my green is again like completely ready, it's completely renovated, you can simply swap the load balancer from your blue environment to green environment. So this transition is going to be very quick, and your users will never experience the broken state actually. So this is how we can quickly shift your entire traffic from A to B, that is basically from blue to green. So if something unexpected is going to happen, okay, once you are done with the transition of the load, if something unexpected is happening after the switch, so your rollback again is going to be very immediate. You just need to send the traffic back to blue. So this is how blue-green is extremely useful for your large releases. Or in again, like if you can't afford any kind of downtime on the application, so in that use case as well, blue green is going to be playing a very important role. Okay, so we do have a comparison table here. Okay, basically we are trying to compare the deployment strategies. Okay, I do have some more time. Okay, so this is the table we do have for the deployment strategies. So we'll just go ahead with this. So feature flags we do have as a first technique here. Okay, so feature flags are very perfect for any kind of UI changes, or if you are basically dealing with gradual rollouts and A/B testing. And here the risk is very low because here the rollback thing is very instant, and they won't be. You just need to toggle between on and off. So that is how feature flags are here. Then we do have dark launches. Okay, so dark launch is best for backend testing, or if you are dealing with infrastructure upgrades as well. And in dark launches, user will never see the new behavior until you are ready. Then we do have canary deployments here. So canary deployments is gonna really shine when you need to when you need real production validation, but you also need a controlled exposure as well. So in the canary deployments, you only need to expose a very small amount of traffic at the first place, and then you can basically go ahead and roll back, and this process can be automated too. So that is all about canary deployments. Then we do have blue-green deployment. Okay, so blue-green are great for, as we discussed like in the previous slide itself. So they are great for big releases where like downtime is not affordable. Downtime should be zero. In this use case, blue-green are going to play a really great role here. And again, in blue-green, you'll have to maintain two different environments, and you need to basically switch from one environment to another whenever the second one is ready. So considering this all techniques which I have mentioned, okay, so there isn't one single best approach we can say. Okay, so mature teams are like really serious kind of teams. So they actually combine these multiple strategies. For example, we can say that dark launch as for the backend, and control flag exposure using the flags, and you are basically using canaries for the deployment, and you can again like basically taking blue green as a final safety layer. So combining these all strategies, you can basically be more comfortable with the deployment, and you can be more predictable. You will be having a more controlled and a stress-free production. So this is all about this particular table. Okay, so coming back to the next thing here. So how exactly these modern pipelines are supporting safe deployments now? So everything that is going to begin with GitOps. So you have to store all the configurations and all the manifest files in the Git. And this is going to make your deployments very versioned and auditable as well. Okay, so next we do have is CI/CD. We have multiple tools in the market for CI/CD, like GitHub Actions. We have Jenkins, we have GitLab CI, we have Octopus. So which are gonna basically automate, build, test, and roll out the workflows. But automation itself is not going to be enough, of course. So you also need to observe the things as well. That is basically the observability part we do have. And we do have tools like Prometheus, Grafana, Datadog. So multiple tools are there which are going to give us real-time metrics like latency or error rates or the CPU usage, log traces. So multiple things are there. And then we do have feature flag platforms like Harness is there, Unleash is there, I guess Launch Darkly is there. So multiple things are there which are going to give us a more control layer. I do have less time, so I'm just going to quickly wind up. So we do have this slide of Octopus Deploy plus GitOps here. So instead of deploying directly into the Kubernetes or directly into the any platform where you're hosting the things, so Octopus is gonna update the Kubernetes manifest which are stored inside the Git. And this basically means that your Git is gonna remain the single source of truth, and everything is gonna change in a kind of very versioned and reviewed and auditable manner. And then we do have this Argo CD or Flux. So these GitOps agents are continuously going to watch the repo where you have stored the base code. And when they are basically going to detect a change, even a minor or major change, so they will automatically sync the same to the K8s cluster in a safe and controlled manner. And this is basically going to prevent the configuration drift. And it is again going to help you ensure that your production is always matching the Git, whatever the updated things that you're having in your Git. So that should be always matched with the production. So this is what will be taken care by here. And even the feature flags we are having, so we can store the same in Git as well. Okay, so like using the config maps, or we are having CRDs as well. So using this, we can store the same in Git. And for rollout strategies, okay, so we are having Argo CD that is going to take over, and like if we are handling the canaries, or we are checking the metrics, so or even if we are dealing with shifting the traffic as well. So these all things can be taken care by rollout strategies. And then we do have, if we are basically putting these all bullet points into one, so we can say that your flow is going to look like Octopus, from Octopus to Git, from Git to Argo CD, and from Argo CD to cluster. So this is how a clean and a reliable pipeline that is having a blend of automation, versioning, and sifting is going to look like. Okay, this is architecture that I have. Okay, so let me just skip this, and I'll just come back to this the same if I do have some more time. But before that, we do have this demo setup, a very quick and like interesting demo I have created around feature flags. Okay, so in this demonstration, the intention here is very basic actually. So we just need to highlight the fact of feature flags here. So we are going to use a very tiny Node.js application that is going to serve a basic web page, and there's a flags.json file that I have created, and that is going to hold the state of the feature flag. Okay, so whenever the flag is set to false, the feature is technically deployed, the code is going to exist, but the user won't be able to see the new feature on the product. So that is how a classic dark launch is going to look like. And whenever we are basically changing the flag to true, the feature is going to appear instantly without restarting the application, or without redeploying, or without redeployment of the new product. So that is how this feature flag is going to work. So because whenever we are basically changing the flag, or we are toggling between on and off, the app is going to read the final file, the flag file which is there, and on every request, the updated like the whatever state we have changed of the flag, so that effect is going to be very immediate on the production. So that is how it is working. And this is a very tiny demo we are having, and the whole philosophy of this dark launch or feature flag we are having. So this all will be covered, and basically will be able to deploy anytime, and we will be able to release it whenever we are ready. So that is what the demonstration is. So let's jump into that. Okay, so this is the source code I'm having. Okay, so this is the code of the application. It's a very basic Node.js application we do have, and here is the flags.json file we are having. So currently you can see the flag is set to false, and the application is already running. I had ran it previously, so the flag is false right now. So we'll just go to, okay, here you can, only thing you can observe here is welcome to my app. This is what it is printing. But if we are going back to the code, and if we are changing this to true, we are just changing this, we won't be rerunning, we won't be redeploying, we won't do anything. I just updated this from false to true. Now if we are going ahead and refreshing it, you can see new feature banner enabled. So this is how exactly we can toggle between true and false, and we can the classic thing, like we can deploy anytime, but we can only release when we are ready, and it will be only visible to the end users when we want it to be visible. So that was a very tiny demo I had. Okay, so we have another slide here, what best practices that we need to follow whenever we are dealing with these all concepts. So feature flags are really very powerful, but if you are not handling them properly, they can introduce a lot of chaos, and like we need to be very careful whenever we are dealing with them. So first thing we can talk about is we need to remove the flags when they are not needed at all. Okay, so cause if you like unknowingly, if you kept the old flags, so they are going to turn into kind of zombie flags, we can say, and they will be very confusing. That will be very risky. It will be very complicated to maintain the flags as well. Then we do have adding the TTL flag. Okay, so if a flag is meant to be live for only for 2 weeks, and you basically want it to expire after that, so this is going to prevent a long time clutter as well. And we can talk about log flag evaluations. So whenever you are dealing with debugging, it's going to be incredibly helpful to know which flag state or which user saw at which particular time. Then we can again like separate deploy from release. So this is again a best practice that we need to follow. So there won't be any need to tie deployment and releases together. So you can deploy small and you can release intentionally. Then we have automated rollback conditions as well. So if your error rate is spiking beyond a threshold, the system should revert the same. So that is a best practice. And one last best practice I have mentioned here is that you can couple the rollouts with SLO based on the alerts. If your reliability is going to dip, or you are basically trying to stop the rollout at a very urgent basis. So these are some of the best practices I have mentioned here. But apart from that, also there are many things that we can take care of. I guess I have already crossed my time. So that was the session from my side. If you have any questions regarding this particular topic and regarding the architecture, which we couldn't discuss in the session scene, so you can basically simply scan this QR code. You'll be getting to my LinkedIn, my Twitter as well. So you can just basically ping me there. I would be more than happy to discuss the things with you and like resolve your queries as well. And if you want this presentation as well, so I can share that too. So that was the session from my side. Thank you.
Awesome. Thank you very much, Rajni. That was wonderful. Really appreciate you taking the time to explain things. Also, we're a big fan of Okta. So can you tell us a little bit about some of the work that you do there?
Yeah, so I have recently joined them. So my team is basically a completely new team that we are in India. They have created this team from scratch, and we'll be basically dealing with the creation of standard images. So what exactly we'll be doing, so that work is still in discussion. We are discussing a lot of things. We are taking feedback from a lot of different teams, and we are figuring it out, like what exactly is supposed to be done. So I'm a newbie actually. So it's just been 3 months for me.
Awesome stuff. Well, there you have it, folks. Thank you very much, Rajni. We really appreciate the time for you to present on all those great things.
Yeah,
thanks.
Thank you.
All right. All right. We are forging ahead. I'm going to welcome Felix to the stage now. Hi, Felix.
Hi,
so
John.
Up next, hey, how's it going? Felix is a seasoned veteran of Shipped. He's joining us from last year. He spoke last year at SHIPPED25. So coming up next, let me bring up the schedule here, and I'll set you up here, and we'll get you going here, Felix, right away. So coming up next, we've got Felix, who's going to do a talk on mirror first blue-green deployments with Octopus and Istio. So blue-green deployments, obviously, this is a modern twist on a deployment classic, as I like to say it. So it gives you instant rollback, but one of the challenges with blue-green sometimes, at least I find, is that there's that blind spot. You really don't know what the new version or how the new version behaves until you actually flip the traffic over, and that's part of the challenge. So Felix, as I mentioned, he's a veteran of the Shipped speaking tour, and he's going to be talking to us about Istio and Octopus. He's going to be talking to us about, obviously, mirror first blue-green workflow with Octopus and Istio, and that's the service mesh that folks are accustomed to. So anyways, welcome, Felix. Over to you. I'll go ahead and share your slides, and the stage is yours.
Thank you so much for having me. All right. So welcome to my session. First of all, can you hear me all right? Let me just check it again to be sure. Okay, yeah, looks good. Welcome to my session. It's called Mirror First Blue-Green Deployments with Octopus and Istio. And for the beginning, I want to just take you through the agenda. First, we're going to hear a little bit about me, and then we have a theoretical deep dive a bit. We are going to answer the question, what is a service mesh? Also a short reminder to what blue-green actually is before we then get to my core of the talk, my mirror first or the mirror first approach. Before we then go over to some gotchas and some key takeaways, and then answer the question, what else can you do with the service mesh? And then we have a little bit of QA time planned. I'm not sure if this is going to be needed, though. Okay, so first, about me. My name is Felix Notka. I am a senior cloud consultant at Pexan Consulting GmbH in southern Germany. And you can see me on the right at KubeCon London 2025, along with a lot of really cool Octopus people, and I'm the person with the blue jacket in the middle. Why am I the person in the blue jacket? Because I am a CubeSonaut, and many of you will be probably asking, okay, what is a CubeSonaut? It's a program that the CNCF launched at KubeCon 24 in Paris, and there are currently approximately 2,650 CubeSonauts worldwide, of which there are 153 in Germany. In order to become a CubeSonaut, you have to hold 5 certifications at the same time, which are the Kubernetes and Cloud Native Associate, the Kubernetes and Cloud Native Security Associate, the Certified Kubernetes Application Developer, and the Certified Kubernetes Administrator, as well as the Certified Kubernetes Security Specialist. And you can see here all of the CubeSonaut who attended the same KubeCon in London in 2025 on stage, and all of them have cool blue jackets. But on that same KubeCon, the CNCF launched a new program, which is called the Golden CubeSonaut. There are a lot fewer people who have this title, approximately 200 worldwide, exactly 19 in Germany. And on top of the 5 Kubernetes certifications that you need to hold, you need to have 10 additional Kubernetes certifications. And you can see here the list. There's stuff that's quite theoretical, like, for example, the Certified GitOps Associate or the Certified Cloud Native Platform Engineering Associate, which deal a bit more in concepts. And you have exams which focus on tools around the Kubernetes ecosystem, like, for example, the Prometheus Certified Associate. And when it was launched, a couple of people asked me, oh yeah, Felix, are you going to do the Golden CubeSonaut? And I said, no, not really, because and my argumentation back then was, I don't need to use a service mesh. In my mind, a service mesh was something that only really big companies use, with a lot of clusters, with a lot of complexity. And that's honestly way too much for me and my projects that I've had so far. And as you can see here, the first exam on this list is an Istio Certified Associate, which is a practical exam. It's supposed to be extremely difficult. And I was like, no, not really. I'm perfectly fine staying just a regular CubeSonaut and having my Kubernetes knowledge. And yeah, as maybe you can see a bit ahead, that didn't stick. About 3 weeks ago, I became the 17th Golden CubeSonaut in Germany. And it took a while. It was really interesting. It was a lot of certifications and exams. But some of you may ask the question, okay, why though? What really changed? And to be honest, it just started when I typed into Google, what is a service mesh? And service meshes are an incredibly interesting concept, which you can do a lot of stuff. And in my talk, I hope to show you a little bit of it and give you a taste for more, but there's definitely more stuff that you can do with it. But to explain it, a service mesh is a dedicated infrastructure layer added to a Kubernetes cluster to manage, observe, and secure communication between microservices. It does so by automatically placing a tiny lightweight proxy alongside every single application container. Most of the time, that's an Envoy proxy. That's a small little application that's written in C++ and developed by Lyft a couple of years ago, and it's incredibly performant and incredibly cool. But these proxies intercept the network traffic entering and leaving the services, and they manage the data flow without the application even being aware that they exist. And the whole goal of a service mesh is to try to decouple the business logic from the network logic and ensure that security, reliability, and observability are applied uniformly across the entire cluster. I also have a small little diagram here, and this is basically the way that pod-to-pod communication, very simplified, works in a native Kubernetes cluster without a service mesh. So you have on the left container A, and container A wants to talk to container B. And in order to achieve that, container A goes ahead and basically pings the service B. And the service B is sort of like a router and a load balancer. And the service B strictly just goes ahead and says, okay, I have a request here that came to me, and it wants to connect to a pod that's, for example, labeled app equals container B or something like this. My absolute favorite analogy here, which I think most of us can absolutely relate to, is to imagine yourself back in school. And imagine yourself that you are a pupil and you are container A and you want to talk to your friend, which is container B. But in the middle of you, there's a person who's new at school, that's our service, and it's his job to sort of forward the message. So back in the day, you had a piece of paper, you wrote your message on, and then you folded it in half and wrote the name of the person you are trying to reach, in case you're a friend. Let's just say the friend is called Mike or something. So you as container A have your small little envelope with the name Mike, and you pass it over to service B. And service B, the person in the middle who doesn't really know anything, is looking to the right and checking, is there a person named Mike that is supposed to be container A's friend? And if so, I'm going to give him the note. And with that analogy, I think we can all spot a little bit of issues here. For example, what happens when, I don't know, someone who's not supposed to read the message just comes along to service B and says, oh yeah, hey, I'm Mike, you can give me the message as well, because service B will forward this message, and this is a bit troubling. Also, as container A, you have no idea if your message really connected to where it's supposed to go. You have no idea how long it took and which path it took. And so a bunch of really small people have gone ahead and have created a service mesh. And the diagram that I'm showing you right now is a bit complicated, but with that analogy, I think we can get through it quite easily. So the goal is still the same. We are a container A, and we want to talk to container B, which is our friend. And because it's almost Christmas, we can say that the school has a special exchange program where magical little elves appear. And these magical little elves all of a sudden come to every pupil in the school and tell them, hey, I'm a messaging elf, and I will take over your complete communication via messages. And in the school also there is sort of the brain of the whole elf agency, which configures them and tells them what to do. So instead of you passing the note to service B, you go ahead and while you do that, so the application thinks it's still targeting service B, the elf comes along and takes your message, and then the elf will look up the person you're trying to reach. So for example, as I said, your friend Mike, and will then connect to your friend Mike. And it does so not directly to him, but the elves, your friend's elf will intercept this message as well, get the message, and then forward it to your friend. And the good thing with these small little helpers is that we can teach them a lot of stuff. And because they are centrally managed, we can tell them, okay, for example, you want to be in encryption and you want to have MTLS support. Then all they would have to do is take your message, put it inside a big metal bag, and then carry it around to the elf of the person you're trying to reach, where they then could check their certificate, and if it's really the person you're trying to reach, and then decrypt this message. Or for example, these helpers could go ahead and could write stats about how many times they went from you to whatever friend you were trying to reach. And this is incredibly helpful for observability, for security, and for reliability. And as we can see here, and to recap, the goal of a service mesh, or a major benefit of a service mesh, is to decouple the business logic from network logic. It lets developers focus on features, meaning communication between you and your friends, while the helpers focus on stuff like security, authentication, authorization. It's also incredibly helpful to allow you to have uniform observability. Since the helpers can automatically gather metrics, logs, and traces across the entire cluster, it's not really that important which tech stack you're running, and you don't need to focus on every single application. Also, as I've said, zero trust security, major thing in Europe right now with NIS2, and service meshes are a good part to get started with that. But with that, you can enforce uniform security policies and encrypt traffic between services. You can also go ahead and tell your applications to only receive traffic from these amounts of, or from these specific entities, and only to send out to specific entities. And you can have a little bit of fun, which is the advanced traffic control. You can do precise data flow management, including canary deployments and circuit breaking. And this is what I will show off later a bit. But basically, we can tell our helpers, if I get a message and the person who sent me this message is my friend Steve, then I need to handle it differently than if it were any other friend. So when should we actually use a service mesh? The most common use case is for complex microservices, because then you can offload network logic like retries and timeouts from the code to your infrastructure. Also, what I've said just now, the polyglot environments. If you have different applications with different teams managing them, and all of them need to go ahead and learn about and implement very specific language SDKs, then that can take a huge amount of time. But if you can have a centralized observability strategy, and every package of traffic that is sent across your whole cluster can be logged or configured in a specific way that you can see it afterwards, that just alleviates a lot of pressure from the teams. Also, if you have strict security guidelines, if you want to have MTLS support throughout the whole cluster, without really doing any code changes, or if you want to have an authorization or authentication policy cluster-wide, that is also really, really helpful. And the last part is for advanced releases. So we can have the traffic shifting like canary and blue-green support directly at the network layer, instead of outside on the load balancer level. But we will see all that a bit later. And first off, I think we have to have a small course through what are exactly blue-green deployments. Even though we've heard it fantastically before a couple of minutes ago, I unfortunately need to repeat that because it's in my talk. First, blue-green deployments is a deployment strategy that uses two identical productions environments, blue and green. And blue in this case is the current one, and green is the idle one. A new application is deployed and tested in the green environment, while blue continues to handle the user traffic. And once green has been verified, a load balancer switch comes along and just reroutes the traffic from blue to green. And this means we have almost no downtime during the deployment, and we can switch back and roll back really, really fast. But after a successful deployment and after it's been tested, green becomes the current one and blue becomes idle. We can see that in this diagram as well. So we have user traffic hitting our production environment through our load balancer, and our load balancer routes all traffic to the blue instances, in this case V1. We have an idle application instances stack, application V2, this is green, but this is not used anywhere. They both share a lot of resources like the database, because only one of them is supposed to be active at once in a blue-green environment. And after we've checked everything, we can just switch the load balance around and have app v2 user-facing, and the blue instance is now the idle one and can then be used for example, application version 3. And we can have this exact diagram just a little bit more technical. with our service mesh. So in this case, we have user traffic hitting our Kubernetes cluster, and the ingress gateway will then take the traffic and route it to 100% to the blue instances and to 0% to the green instance. We have our control plane, which configures all of that. And this is nothing else than basically this diagram, just a little bit more technical. And the same works for if you want to switch traffic around. Then we only have to configure the ingress gateway configuration, and then our traffic will be routed to our green instance across, instead of our blue instance. So what are some strengths that blue-green offers? First of all, we have almost zero downtime because the traffic switches instantly to the newer version via the load balancer. We don't have to wait for a redeployment, which could take synchronously about maybe half an hour, in which we are unable to do really anything because we're waiting for our applications to spin up. It also allows us to have an instant rollback. If we switch to our new version, to the green environment, for example, and we see a lot of errors coming along and a lot of users calling us and saying, hey, I think you've broke something, it's also easier to roll back because the blue version is still active and it's still theoretically absolutely functional. The only thing it needs is real user traffic. We also have a real-world verification because both are genuine production environments. Both the green and the blue environment are scaled the same and can handle traffic the same. So it's not something that has to be scaled up or scaled down. Both of them should be resource-wise identical. And it also isolates our risk a bit because typical things that go wrong in deployments, like crashes or resource spikes, happen only in idle environments. So they do not affect real users because real users are still seeing the blue version instead of the green one. But it also has a few limitations. The first one being you have double the resource cost if you have twice the environments. And it also requires maintaining two identical production environments, and this can all be a bit costly. Also, the dependencies, like for example, a database migration is a bit tricky because every database migration has to support both versions at the same time. Otherwise, you would lose the ability to roll back, which is so critical in blue-green environments. Another tricky thing are stateful sessions, like caches, and if you have long-running user connections, you can risk disruption to that. There are mechanisms to sort of terminate them gracefully, but if they are not in place, this is just a little bit of extra caution you need to take. And the last point is because traffic is switched all or nothing, that means if a bug somehow slipped through testing and didn't really come up until you have switched your whole traffic over to the new version, you roll back even if you say you are quick and you have just 1 hour of the wrong version running with a bug in it, then you would still have 100% of users at this time hitting your wrong and your bugged version, which is not, of course, not optimal because this can mean corrupted database entries or wrong user data, and there might be a way to sort of do this a bit better with a small little hack, which I call a mirror-first approach. And the theoretical idea is quite simple. We are shadowing our production traffic. We can tell our little helpers that they need to duplicate the live incoming traffic and route them to a newer version of our application. That's a bit like the dark launch that we've just heard. And it sort of combines the idea between blue-green deployments and dark launches. Also, what's really important, the mirror has to have a fire and forget execution. This means the response from the mirror can never reach the user because you're testing this application and you're sort of need to handle the way in which the application, for example, just has a bug in it. And you want to spot the bugs and you want to see the bugs, but it's unhelpful if you send the messages out to the user anyway, because then you could scrap the ID entirely. Also, it allows you to test the new version against real-world data and volume with zero risk to live user experience, because users will still only see our V1 while the V2 is being tested, but no one has any clue that is really being tested, because we hide the responses and we hide the traffic, and everything just gets copied over to the next instance. I also have a diagram here. This is the same one that we have seen before. So in here, we are all on the application V1, the blue environment, and we have deployed our application V2 to the idle environment. And so far, all of our tests have gone through, and we would, in theory, be ready to switch the traffic over to the new application. And instead of just switching the traffic over to 100% to the green proxies and staying on the left, we add another shadowed instance. And this shadowed instance also receives 100% of the gateway traffic that comes along, but importantly, it doesn't share the same database as the blue and green environment. Because if there were some bugs and errors in the shadowed version, we would still corrupt our database, and that's not something we want to have. And after this has been successful, and we can see, okay, our shadowed version works as expected, which is the same version that we plan on deploying to the green instances, we can then go ahead and delete our shadowed instance and move traffic over to the right, to the green instance, and have users hitting V2. So how does mirroring change the blue and green flow? The shadow phase silently processes copied live traffic before serving real users, and it validates the infrastructure against actual volume and behavior, catching bottlenecks synthetic tests miss. Also, the failures that happen in isolation. That means live users remain absolutely unaffected on the stable version because the other one is just isolated away. And the switch becomes more of a database decision than just sort of a leap of faith after your QA team has gone through. And then you can say, okay, my metrics, my logs, and my traces look fine. We have had a lot of users hitting our application that would have not normally happened in our load test because, for example, our load test only uses like 10% of real user traffic. And if that all works, you can safely switch over to it, and you have a better understanding how your application could perform, because it's basically a hidden rehearsal of what would happen if you were to switch over to the newer version. But it doesn't help everywhere. In the cases where it's incredibly helpful is if you have services which are stateless and read-only. So something like search, recommendations, or data retrieval, where it doesn't matter if you process the same request twice. It's also fantastic for validating behavior under real concurrency and database load without risking the live user experience. And in my opinion, it's absolutely fantastic for refactoring verification. That means you have a piece of code that has been written in a legacy system, and where you say, okay, this is either a bit slow or it's a bit buggy, and I want to make sure that the refactoring that I've done produces the same identical output. And the way that you would typically hear and typically go about is that you go ahead and you have your tests that go through. You have, for example, some load tests which try to emulate real user behavior, but it's not really the same. And there can be instances where a small little bug in an edge case, it's not tested, but a lot of users, for example, happen to do that by accident. And with this way, you can afterwards compare the outputs. You can go through the logs, which should be fairly identical. You can see the backup database, which should contain sort of the same entries. You can run queries through both of it, because if you mirror 100% of the traffic, the shadowed version will behave as if it weren't shadowed. But there are also cases where it just doesn't help. For example, it's absolutely not helpful for testing new features. Mirroring replaces the existing traffic patterns, and that means everything that you've added in your newer version that cannot be accessed in the old version cannot be tested. If you have a website and you add a new button on there, and you try to shadow the traffic over to your V2, no one in V1 will be able to hit the V2 button because it's just not there. And also you have to be a bit careful for external side effects. That means duplicate calls to third-party APIs like emails or payments. They occur as if it was a live application, and that means that every dependency must be able to be injected and must be able to mocked or stopped. Otherwise, you would risk real user impact with duplicate emails, and like worst case, I think would be a double billing or something, just because you've tested anything. But you cannot do it out of the box. There are some preconditions that you need to have in order to be able to pull this off. And the first one is you need to have a service mesh infrastructure. That means you have to have a Kubernetes cluster with Istio or something similar, and the apps must have sidecar proxies for traffic routing. If you try that without our little helpers, you won't really get far, because they just enable you the possibility to do these kinds of advanced traffic routing things. It's also important that you have a bit of spare CPU and memory to handle the combined load of 100% traffic, plus the mirrored shadow traffic simultaneously. It's another environment that you put up, and because you already have blue and green, you have 2 environments more, and you just need to be sure that mirroring and shadowing your traffic does not impact your cluster's maximum CPU usage to a point where you cannot handle it. Also, sort of the major idea behind this whole system is that you can see what's going on. If you don't have a good observability strategy, and if you don't have robust signals that you can compare to each other, and a good strategy of how you actually measure the success in there, it will be a bit difficult to go ahead and see if your application really works the way you want to. And for that, I have a sort of a practical demonstration how this could and should look in Octopus Deploy and in code. So here is my mirror blue-green example, where we have an application that has 5 environments. It has a dev environment where you can deploy to, it has a test environment, and then before it would typically go over to prod blue or prod green, there's an optional mirror environment. And this optional mirror environment needs to be discussed if it's even helpful. As I've said, if you're testing a new feature, then this won't really help you. But if you try to do so and you have everything prepared, you know that the feature you're trying to test is a good candidate for that, then it all just comes down to how you configure it and you code it in Octopus afterwards. Let me just switch my mirror real quick. Okay. This should hopefully work. Yeah, as you can see here, we have our deployment. And in our deployment, we need to make sure that we have set up everything so that we can handle this kind of scenario. That means we need to be able to distinguish applications by the environment and by the color and by the app name. The app name is something that's typically in here, but the color is important for us to use. And also here, we said this is just done for a Node.js application, and everything that's in here is posted to my GitHub, and I will give a link at the end where you can find all those files. Other than the deployment, we have, of course, the service. This is all just Kubernetes native. That's nothing new. That's nothing special for the service mesh solution that we have. But where it gets interesting is, first of all, the namespace, because we have to configure the Istio injection. That means that our sidecars will propagate our pods, and we have the ability to do the advanced traffic routing. And then we need to configure our subsets in the destination rules. And here you can see we have the blue environment, the blue subset, we have the green subset, and the shadow subset. All of them basically boil down to the label color blue that we have in our deployment. So we have labels color blue here in this variable. After we have our destination rule, we can reference it in our virtual service. And this is sort of like the key thing that handles traffic routing in a service mesh or in Istio especially. Here we have a service that manages our traffic based on the 7th layer. That means we can do ingress and egress, and we can handle it really, really outside and far up the stack. So we have access to a lot of information and a lot of tools. Here we have 2 different routes, and the first one is our route to our blue subset. This is just the path that you need to take to have in-cluster routing. And here is basically the port number or the container port that we want to use. And what's special here is we have 2 routes. We have our blue and our green route, but in here is the small little flag that says wait. And if we want to deploy to the blue instance, we can just say here we want to have a weight of 100, and we want to have here a weight of 0. And this we can do and switch on every deployment so that we can switch back and forth. What we have here is the mirror section that tells us this is the host we want to have with the subset shadow, and we want to mirror a percentage of that traffic. This can be 100%, this can be 1%. I don't think 0 makes any sense. But here you can configure basically the amount of impact that you want to have. And then the rest in here, it's just our Istio gateway. That's something that we just need to have here in order to tell the traffic where to actually be able to go and to route to our applications. And we have a peer authentication that's for MTLS. In this repo, you can find also the variables in Octopus form, which basically says what percentage should go where in which environment. And as I said, you can find everything that's on here at the end of the presentation in a GitHub link. So going back to our presentation. What are some gotchas and some pitfalls that we need to be aware of? The first one is, of course, the proxy overhead. The mirroring logic runs in the sources sidecar proxy, requiring it to serialize, copy, and transmit every request. That means we have to be careful that scaling something up doesn't affect our source application too much, because it's the source that eventually goes ahead and copies the traffic over, not the destination. And the source is the thing that we really need because it's the application that our users are hitting. The other is the latency risk. And it's basically just the consequence of the thing above, which means if we have a lot of packages and a lot of requests that come through our source pod and our cluster is not able to handle this kind of traffic, then it can be that we introduce a bit of latency or even drop packages. So the solution for that is that we must provision some extra CPU headroom for the sidecar containers and not just the app before enabling mirroring to prevent starvation. But that's something you can try out a little bit afterwards and just increase the value to a bit and see how much performance that really costs you. The other one is not only the CPU, but also the network, because copying traffic effectively doubles the package count leaving every pod. And this means you have to be careful if you're in the cloud, because if your mirror runs in a different availability zone, then all of a sudden you have a massive cross-zone data transfer. And this, of course, costs. And the third one is the solution for that, to basically go ahead and make sure that the mirror and the live targets are near to each other, so that you have as less latency as you can possibly have and as less network traffic that you need. Also, it's important to beware of the side effects in the mirrored version. The mirror version in of itself believes it is live and believes that every user request that comes through is from a genuine user and not copied. So if you have a dependency in there, or for example, an endpoint called charge credit cards, the mirrored version will absolutely go ahead and call that endpoint if you have not mocked it. So you need to be careful here, and you need to make sure that a lot of the preparations have been done for this and that you can do this safely. So as I've said here, you need to redirect the external dependencies either to mock servers or to something else, so that the consequences of those traffic requests never actually hit your users. Also, there's a cold cache bias. Typically, when you do a mirrored instance, you want to see the performance. But what you need to also incorporate is that your V1 is fully optimized. That means the caches are warm and connection pools are established, and your V2 starts off completely cold, because you should not really use the dependencies that you have in V1 for your V2 instance. Otherwise, the mirror could mess with your original version, and that's not something we want. That means V2 most definitely will initially appear slower and more CPU heavy. And this can lead to some false alarms where you can say, okay, that means my new version isn't as stable and isn't as performant as I thought it was going to be. And it can lead to some early decisions that might not really give the whole picture. So I think a mandatory warm-up period of at least 30 minutes to fill caches before even taking a look at metrics is always a good idea. Otherwise, you just get yourself down for something that's not even real, because V1 just had the benefit of being available and alive for a bit longer and filling its caches. Some key takeaways here are that mirroring blue-green deployments allows you to de-risk the cutovers. It means that this high-stress leap of faith deployments where you say, okay, I'm pretty sure that it works, but I'm not entirely sure, is a bit more data-driven and can help you make the decision easier. Also, it allows you to have real-world testing. That means you can safely test against chaotic production traffic patterns and concurrency without impacting live users, as long as you have all of the preconditions like the extra resources for that. But it also means you have to have a high maturity in your applications. That's not a free feature. It demands that you have the ability of having your software run in multiple versions at the same time. And this is, I think, exactly why it's so helpful with blue-green deployments, because if you can run blue-green effectively, you already have this kind of functionality. And always beware, this is a strategic tool. It's not universal. It's incredibly good for refactoring and tuning, but it's often an overkill or just invalid for something that you really cannot test. But if you can do this, that's always a fantastic feeling, because you get so much more insight in your testing strategies and your applications. So that just leaves us with the question, what else can you do with the service mesh? I've just given you a small exempt of the possibilities that you can have, and more of them include canary releases. You can shift traffic based on real-time health metrics. You can limit the blast radius, and you can even go ahead and filter traffic and route traffic based on headers, for example. This is what I've meant when I told that friend Steve should be able to be handled differently than anything else. You can have circuit breaking and retries done by your infrastructure, done by your cluster, without having that in every single application. so you can manage this once and for all. You can also do some chaos engineering with Istio. You can say, for example, that every request to this and this endpoint has a 5% chance of just aborting with the status code 500, or delaying for 1.5 seconds to see what's really going on and how your application will handle some edge cases like this. And it also allows you to have this zero trust security via MTLS, because you can encrypt the traffic and enforce the auth policy on Kubernetes level and on the infrastructure side. And this is my presentation. Thank you so much for having me. Just as a follow-up, my company and I, we are doing a webinar on the 15th of January at 4 p.m. Central European time that talks about compliancy through zero trust with NIS2 and Istio and all of these things, basically.
Awesome stuff. Thank you so much, Felix. That's awesome. Congratulations on becoming a Goldener CubeSonaut. That's awesome.
Thank you.
One of 19 in Germany. That's amazing. Yeah. Awesome stuff. Well, everyone scan that QR code. Make sure you join the online webinar January 15th to learn more about Istio around automating security around that. Felix, thanks again for speaking at Shipped. Really appreciate it.
Thank you so much for having me, and wish you a wonderful conference.
All right. Thank you very much. All right. Onward and upward, as we like to say. We are very short on time. We're coming up to our hard break at 4 hours into this. That's because of LinkedIn. We can't host events longer than 4 hours, but there you go. Just to set the context for the next presentation here, I've got Eric Soundhe, who is going to be doing a presentation entitled Build, Test, and Deploy Everywhere from Cloud to Edge. Eric's actually a member of the team over at ARM, and recently we announced a partnership with ARM, which was great. If you want to read more about this, you can read it on our blog. I'll go ahead and invite Eric to the stage. Eric, how's it going?
Hey, how are you?
Hey,
how's it
I'm
going?
good. Thanks for joining us. Really appreciate it.
Yeah, thanks for having me. I apologize,
Awesome.
my voice is recovering.
No,
done a lot of
you're
talking
fine.
in the last several months, actually, going event to event and meeting with some of your team as well. So, but it's coming back, and I'm looking forward to this. It's really great to.
All right.
to
Well,
be
hopefully
here.
it doesn't give out. If it does, just do it through interpretive dance, I
Yes,
guess.
of
We'll see.
course.
How, yes. All right, Eric, the stage is yours.
Thank you, sir. All right, I'm going to go as quick as I can because I realize I'm the last talk between a break. My name is Eric Sondi. I'm from ARM. I'm here to talk to you about how, through partnership with Octopus, we are aiming to enable developers to be able to build, test, and deploy their software everywhere that ARM is, from cloud to edge. And I'll get into a little bit more about what that means. But I'm really thrilled to be here. And I'm going to start with a little intro about what ARM is for all of you, because not every developer is familiar, especially the higher up the stack you might be, and depending on your experience. I'll go through why now is the time to really start to consider what your architecture you're deploying your software on, what some of the things we at ARM are doing to help you, to help it make it very easy for you to deploy on ARM devices, whether in the cloud, whether on mobile devices, whether laptops, whether it's your automobile. We're trying to make it as easy as possible for developers everywhere to adopt our technology, to make the most of it, and make their applications the most power efficient and energy efficient and performant as possible. And we're also getting into this partnership that John just outlined. So with that, I'll just get right into it. ARM is everywhere. We have over 300 billion ARM-based devices shipped everywhere. Almost every single mobile device, laptop, smartphone, runs on the ARM architecture and is powered by a lot of ARM instruction set optimized software. And we've also been all over embedded devices. Think Raspberry Pis, to Arduino devices, and also a lot of large screen compute, desktops, laptops. We're everywhere. And increasingly over the last several years, that also includes the cloud, where most cloud service providers are now providing ARM-based services. 100% of the largest ones already have multiple generations of ARM-based servers available. And our developer community is massive. And the levels of developers that we support, all the way from the bottom of the stack close to hardware, all the way up to the top, and everything in between, whether it's ML frameworks like PyTorch, or tool developers, or microservice architecture, system engineers deploying to the cloud, all kinds of developers across the whole gamut. And so today we're going to really hone in on more of the cloud part of it and deployment to the cloud. But just know that everything we're doing with Octopus is to enable you to deploy everywhere that you are. And I'll get into more of that shortly. Okay. 50% of the compute shipped in the to the top hyperscalers this year will be ARM-based. We're really thrilled about that. That's a massive milestone. That's something that's a surprise to many folks. They're very used to other architectures in the cloud and servers. They don't think of ARM often as providing the compute that's there in the cloud. But what's really interesting is there's massive adoption across all major cloud service providers, so much so that they're running their own first-party applications and services on ARM's architecture. Now, we've taken what has been very strong in the mobile space, our power-efficient heritage as an architecture, our energy efficiency, our area optimization, and we brought that into the cloud to deliver some of the most performant nodes. Graviton just last week, Graviton 5 was announced at AWS at reInvent. So they're on their 5th generation, empowering so many different end user-facing applications, and not to mention the third-party support for ARM that's all over the AWS marketplace has really just exploded over the 5 generations of Graviton. And that's not just AWS, right? So Axion, just in the last month, these 3 cloud service providers have announced their next generation ARM servers. Axion and Google Cloud has a second node, N4A, that complements their V4A to provide several first-party applications and software, and as well as a wealth of third-party apps. And Microsoft announced a second generation of their Cobalt architecture, and other cloud service providers from Oracle to several CSPs in China are also running on ARM and providing their services on ARM. So what the energy efficiency we get in the data center means is a significant lower cost in deployment of ARM for the service provider. And that often means to you, the end user, a significantly lower cloud bill. And that is driving a lot of software vendors and system integrators to adopt ARM and use ARM and make ARM their primary choice. So we have just a massively growing software ecosystem, all the way up the stack, from the Linux low level to Linux distributions, device driver environments, out to cloud native communities and Istio, like we were just hearing, and Kubernetes, and then also the software ecosystem that supports these large developer communities. We engage through partnership, whether it's Docker and making sure there's wonderful Docker support for ARM, no matter what platform you're running on, or GitHub and the latest developer experience that might be agentic or DevOps, MLOps focused. We want to make sure ARM is there and easy to adopt natively in that GitHub experience, and I'll talk a little bit more about that. And then we cover SaaS and enterprise very broadly, and also the AI and ML frameworks and models and distributors that are out there, everyone from PyTorch to Llama CPP to TensorFlow to Hugging Face, all have ARM's presence really strongly represented so that developers can really easily adopt us. What we've done with GitHub in the last couple of years is we made ARM servers, this new class of ARM server over the last several years. We made it readily available to any developer on GitHub. Starting in June of last year, right, we announced ARM64 servers available just in a preview mode, right, to provide the lowest cost ARM servers available for runners, the lowest cost ARM runners natively available under GitHub, make that readily available to enterprises everywhere. Since then, we've deployed native Windows runners. We've also deployed native low-cost runners for the open source community and for public projects for free, thanks to our friends at GitHub. And then just in August, they made ARM runners generally available. So the adoption has been enormous. It's really wonderful to see more and more everyday developers choosing ARM for their build and test. And we're really eager to continue our partnership and make the native experience even more seamless. We continue to work with GitHub and other partners to make it easy to migrate and adopt ARM. And we do all kinds of things, from providing tooling and the ability to assess the value of moving to ARM through total cost of ownership calculators and migration tools, to performance tools to understand how your workload performs, how to benchmark, how to monitor, and how to enhance the performance and tweak and improve the performance, to a latest class of AI-assisted development tools to enable agentic AI workflows and to enable GitHub's Copilot environment that they've just gone full force with enabling agentic workflows through custom agents just recently at GitHub Universe. And in order to do this, we've kind of taken and created an MCP server that's backed by really three pillars: a range of tooling that help analyze your code base or analyze your containers or your dependencies and ensure that there's ARM support there readily, that matches the latest versions of dependencies, that makes easy, simple tweaks to your containers to make sure they're multi-architecture, and that make changes in your code base to help ease the migration. And this collection of tools is paired with a really robust knowledge base of public information, tutorials, what we call ARM learning paths, ecosystem dashboards that have all these libraries of supported ARM dependencies, intrinsics database, so you know how to micro-architecturally optimize certain elements of your workload. All of that knowledge from ARM experts is just packaged up into the knowledge behind our MCP server. And then we have some prompts that are refined to really help with very focused use cases that typically occur during the migration process. So simple prompts that will help analyze the code base, deploy an agent to that code base, and scan for dependencies and make sure that dependencies are matched or upgraded. They will also do things like look for opportunities to employ intrinsics or micro-architectural enhancements or actually do some of the porting. They will also scan containers and make sure that your containers can be supported and can run on ARM. And if not, provide suggestions or enhancements or upgrades to the dependencies in your packages. They will also just make the container composition multi-architecture for you if it is capable, and actually just make your container ready. So we've taken this MCP server and we made it integrated into a number of different agentic workflows. And we're really thrilled about what we've done with GitHub Copilot. Here's an example of the MCP server running under GitHub Copilot. And here the migration agent uses our MCP server to make the architecture easier. You just specify a new issue, write a simple title, migrate this repo to ARM. Really simple description. Use whatever MCP servers you need. So you could specialize its usage to specific tools, or you could just make it general. Give the whole branch assignment to this custom agent and get the agent working for you. It'll start to work in the background. You can watch it work. You can leave the agent and come back when it's finished. And then once you go take a look, you'll just see what's happening. Their agent will already configure and download the localized MCP server image, make sure it gets started. You'll see the suite of tools that are used and how they might be used to perform your migration. So you can kind of really watch what's happening in real time, or you can come back and look at things afterwards. And just all you have to do is go check out the pull request. Here we can see that the agent decided to look at the Python data processing pipeline, migrating it to ARM, looked at the base images, making sure there was compatibility, upgrading it, looking at the packages, looking at where the compatibility needed enhancement, making sure the container was multi-architecture to build, and went ahead and made a bunch of suggestions and changes and documentation to support that. You can see all of the changes that were made. You can review them. So you have that human in the loop element to not just oversee the migration, but to also learn what was done and become an expert yourself. Look for more opportunities. If you're satisfied, merge the PR, and then you're done. So we think this experience is really going to change the game. ARM has excellent documentation. ARM ecosystem has wonderful tools out there, but to take yourself out of your flow state, go delve into deep CPU-centric documentation when you're just trying to deploy AI in your application, it really takes you out of your zone. we bring this all that wealth of knowledge and experience and technical information right into the agentic workflow, and working alongside with GitHub, you can take advantage of the general coding agents that are available under Agent HQ, or the ecosystem of custom agents like from partners like Octopus Deploy. And we'll talk a little bit about that as well. Bear with me a second here. I'm just going to move this forward. Okay, so in summary here for the migration assistant, we built this is by developers for developers, the developers at ARM that are continuously deploying software to the open source community, Linux distributions, making tools. They built this for themselves, and they also know that what your developer experience is like, and they want to provide you the very best of what ARM can offer and what ARM knows. And with this, we think that there's a wonderful end-to-end automation flow that will help you with the migration process. Now, building and testing with ARM runners and lowering your cost is wonderful. Helping you with AI-assisted agents is also awesome for the developer experience, but there's a piece missing, and that's deployment. Actually getting your software out to where it's going to run and live in staging and in production. And that's where our friends at Octopus really shine. I couldn't be a bigger fan of of the team at Octopus, John, and everything that you do. And so we really have started and announced a partnership, John mentioned the blog, to really help centralize, secure, and make repeatable the software delivery to ARM-based systems. There's already wonderful support for continuous delivery at scale from x86 to ARM servers across multiple cloud service providers. And there's already excellent support for compliant and secure CD with Kubernetes edge deployments. And these areas are where we're really going to focus in the next several months. So you're going to get to learn a lot more about the best ways to employ everything I showed you with GitHub and in other environments, and what Octopus has together to build, test, and deploy everywhere, and have a complete workflow. And what Octopus has done is not really new per se. They've had long-standing support from ARM. Back in 2021, they announced Tentacle for ARM64, really focused on kind of more edge servers, Fat Edge, Raspberry Pi, AWS EC2 instances, or really any hardware that had certain dependencies on .NET. And that Tentacle already got some wonderful adoption, and it was really clear how useful and broad the deployment story could be with ARM from that. But what we really feel is that with this change in momentum, the volume of ARM servers being deployed and made more accessible to all of you, we think that there's a real opportunity here to, with this announcement, simplify multi-architecture deployment so that you can deploy your software everywhere on whatever architecture you need, whether ARMs or elsewhere, and take advantage of all the compute that's out there, because more and more compute is needed to deploy more and more of the applications everywhere that you're deploying. We also understand that it's not one cloud service provider all the time. There's complex deployment that involve multiple cloud service deployment. And the ARM architecture is a common link across all of the cloud service providers I mentioned that have ARM-based servers. So we believe that with working with Octopus, we can provide a really foundational layer for deployment and recipes that you can replicate in a very native deployment strategy and CI/CD solution off the shelf that will handle very complex multi-cloud deployment on ARM, that will also lower your cloud bill and enhance your developer experience and your deployment experience. I really believe in what Octopus does really well with hybrid cloud management. And I think that's another area where a lot of ARM technology is on-prem, especially when you think cloud to edge, cloud to car, right? The development environment involves, sometimes a local rack of boards or a board farm, a fat edge server that is very different from the servers that are in the cloud. So I think this environment can be managed when you have solutions like the things that Octopus Deploy provides you all, and when there's very seamless ability to deploy on any architecture and support the ARM architecture, it will just make your deployment story much more easier and scalable to manage. And I think we're very excited about the future of agentic development. Both companies, as GitHub launched their custom agents for GitHub Copilot from partners, on day one at GitHub Universe, ARM and Octopus were there with custom agents, with MCP servers, ready to go with use cases that were very applicable to our customers. And I think the agent-to-agent opportunity here is really exciting to really have a full seamless workflow that you can handle the build and test natively on GitHub. You can deploy where your actual deployment is with Octopus Deploy, and you can have agents manage the migration details for you, the errors in migration, when the errors in deployment, and the resolution, potential resolution to outages, issues in your CI/CD over time. And that's a story we're really looking forward to developing with our friends at Octopus. And to learn more about how things actually work with the Octopus solution in real world use cases, I invite you to join us on January 22nd for a webinar where Octopus, our friends at GitHub, myself, and our friends at AWS will talk about how all of the pieces come together in an AWS environment to build, test, and deploy on Graviton in a very seamless, fluid way that takes advantage of the very latest and greatest agentic technology, that takes advantage of the very latest and greatest Graviton technology, Graviton 5. And we're really excited to bring this to you and really get into the details. Today, it's a little more high level to get you conceptually aware of why we partnered with Octopus. And we're really looking forward to a deeper show and tell with you all on the 22nd. I'll also leave you with a couple other opportunities here. We have the MCP server that I mentioned. It's currently in a beta. We've actually extended the beta a little bit. It will be generally available soon. But if you want to get started today with a GitHub custom agent and start trying this and maybe give us some feedback and work with us a little bit, sign up for our beta program. We'd love to hear your thoughts on how our agent can work with Octopus's agent or your own agentic environment. What are some of the gaps or what are some of the opportunities? Because we're in very early days with this. So our hands open for you now. And then lastly, we'd love for you to join the ARM developer community and take advantage of all the wonderful resources that are available directly. So you can become a member, you can meet other members of the community across different markets as well, and learn from developers at Meta, at Google, at AWS, all over the ARM ecosystem. And it's just a wonderful place to learn and grow and develop. So I'm just going to flip back to our webinar here. I think that's nearing the end of my time with you all. Covered a lot of ground. Thank you for the time. Thank you for hosting me, John.
Oh, you're welcome. Thank you, Eric. Much appreciated. I know that you had to struggle through that, so much appreciated. Unfortunately, we're going to have to switch over really quickly. Thank you, Eric. Really appreciate it. Thank you for your time. For everyone who's here, just refresh your browser if you're on octopus.com/shipped. We'll see you on the news stream that's available there. Thank you.